Hey, What If fans! What a great day it is. Welcome to the program. I'm your host, Peter, and today we've got a jam-packed show for you. As per usual, we'll be doing a lot of crazy what-if scenarios, hypotheticals that'll thrill you, chill you, fill you, and ultimately kill you, but this show is special. It's the most popular what-if scenarios ever. That's right, the most popular videos that have ever graced the channel. We will be taking you through such diverse elements as dying on every planet in our solar system. We'll meet a time traveler, fall into a pool of piranhas, get swallowed by a whale, swallowed by piranhas, swallowed by a black hole, swallowed by Jupiter, and by a bit of quicksand. And I've got a fun little treat for you. But first, let's kick the bucket on every planet in our solar system. Well, not me. I'll let my astro-hopping assistant, Chase, handle that. If you landed on Venus, this hot planet would crush you like a plastic bottle. It would be painful, but don't worry, it would only last 5 seconds. The longest 5 seconds of your life. And just wait till you see what happens on Mars. It's unsettling. Venus has an extremely dense atmosphere, and with that dense atmosphere comes crushing pressure. Literally, it would crush you. The Venusian atmospheric pressure is 92 times higher than the pressure you experience on Earth. It would only take a millisecond before it started crumpling your spacesuit. After 1 second, your suit's integrity would be compromised. You'd be trapped in the imploding spacesuit with no way out. And that's when your body would begin to collapse. In the next 2 seconds, your skin and muscles would compress, your blood vessels would pop, your organs would fail. Finally, you'd lose consciousness, and just like that, you'd be gone. Venus looks like a beautiful place, but it's deadly. And being crushed by extreme pressure is just one of the many ways you'd die here. Remember the dense Venusian atmosphere? Well, not only does it create crushing pressure, but it also generates the greenhouse effect. Yeah, Venus is hot, instantly boiling your insides kind of hot. Even if you could somehow withstand all that bone-crushing pressure, the heat would get you.
Oh yeah. This feels hot, like, being toasted. Like bread being toasted. You guys know what toast is.
Warning. Internal temperature rising.
The surface temperature on Venus reaches 465 degrees Celsius. That's almost as hot as the lava coming out of Earth's volcanoes. You'd be feeling the effect of this intense heat within seconds. After 1 minute, your internal temperature would start rising. Cue heat exhaustion.
What if, guy, I don't feel so good.
Body temperature 40 degrees Celsius and rising.
At this point, you'd experience nausea, fatigue, and extreme sweating. Your internal organs would start to overheat.
It's getting dark. It's getting dark.
After 10 minutes, you'd lose consciousness. Now, you'd just have minutes left before suffering brain damage and complete cardiac arrest. Okay, quick brain fact. Did you know that curiosity is one of the only emotions that actually rewires your brain in real time? The moment you lean in to understand something, like you are right now, your neurons start building new pathways. When you watch curiosity-fueled content like this, your brain treats it like active learning. decoding, and making sense of new ideas just like it does when you solve a puzzle. So, watching our shows is literally good for your brain. Well, that's why we launched the Popular Science Fast channel, where you can stream all our shows 24/7. Tune in any time of day and you'll find mind-bending science from us and from some of the world's leading creators, including NASA's spaceflight, Hacksmith, and Complexly. Plus, live rocket launches, documentaries, and deep dive specials. It's basically a non-stop feed of curiosity, always on, always learning. We're currently available on 10 different platforms, including Vizio, Roku, and Plex, but we're just getting started. We're reaching tens of millions of homes and streaming devices all over the globe, and that audience keeps growing every month. And the channel just keeps evolving. We're adding brand new series and specials monthly, from breakthroughs in tech to space exploration coverage you can watch live. It's a front row seat to the new space race, alongside a 150-year-old legacy of science storytelling now being brought to streaming for the first time. So, if you ever finish one of these streams and still want more, well, you don't have to wait. You can jump straight into Popular Science and keep that curiosity going. It's there 24/7, ready whenever your brain wants its next aha moment. On this planet, heat stroke is no joke. Nothing's a joke here, really. The Venusian air is unbreathable. It's made up of 96.5% carbon dioxide and 3.5% nitrogen, which means taking just one breath of this atmosphere would suffocate you. And if that's not enough, Venus's sulfuric rain would corrode your spacesuit and burn your skin. As far as the survival situation on Venus goes, it's a 1 out of 10. Would not recommend. Now this is Mercury.
The closest planet to the sun, like I haven't just suffered a massive heat incineration already? Come on, what if guy?
Well, Mercury has a little secret. It's actually extremely freezing, at least on the night side.
Surface temperature, minus 180 degrees Celsius.
Yeah, of course. I knew that. Everybody knows that. And here, I'll let you in on a little secret. What If Explorers Club on Patreon is on a roll. That's right, get access to early episodes, and you can see me die. A lot. I die a lot.
Here's the thing about Mercury. Unlike its planetary neighbor Venus, it doesn't have an atmosphere. And without an atmosphere, there's nothing to trap the sun's heat and keep it close to the planet during the long Mercurian nights. Even though Mercury is just 58 million kilometers from the sun, as soon as night hits, it cools down rapidly. When you first land, you'll be okay. You could walk around and explore the planet.
Yeah, Rico, there's like a little numbness in my fingers. Is that normal?
Numbness in the extremities indicates the early stages of hypothermia.
Nah, I'm okay. It's like minus 180 degrees here, you know? Of course it's a little chilly. What a shocker.
Hypothermia would take a little time to kick in. It starts with a tingling feeling in your fingers, then suddenly you begin to shiver.
Yeah, I don't feel any shivers. Okay. Maybe I feel a few shivers, but it's not that bad.
Warning, your body temperature has dropped to 35 degrees Celsius.
Can't feel my fingers.
After 10 minutes in this extreme cold, you'd barely be able to move.
Warning, core body temperature at 32 degrees Celsius. Return to the spaceship immediately.
Your muscles would feel stiff. You'd feel confused and cold.
There was at least 102 Dalmatians.
You'd feel extremely disoriented. Everything would slow down for you. But you wouldn't die. Not yet.
Warning, core body temperature now 28 degrees Celsius.
even now, you'd still be alive. You could barely function, but you're alive. It would take about 60 minutes for Mercury's dark side to kill you. Slow, cold, and painful. But hey, at least you'd get to see some of Mercury's views before you collapsed from the extreme cold. I'd give Mercury's night side a 3 out of 10. But Mercury has a day side too, and it's burning hot. The temperature here hits 427 degrees Celsius, just slightly cooler than the temperature on Venus. And it's not the intense heat that would kill you, it's extreme radiation too. You'd feel all of it the moment you stepped out of your spaceship. Your body would start overheating. If you didn't have the protection of your spacesuit, your skin would immediately get radiation burns.
My hands! My hands are burning! Ah!
It wouldn't be pretty. All that radiation would quickly damage your DNA. It takes 1/1000th of a second to kick off that process. Within the next hour, your cells would mutate and die. So make sure to wear a spacesuit, no matter how hot it feels.
Danger. Core body temperature increased to 39 degrees Celsius.
After 5 minutes of these burning conditions, you'd begin to feel the effects of hyperthermia. If your suit's cooling system were to fail, you'd experience an amount of heat you've never felt in your life.
God, it burns! My hands! Oh, it's like they're on fire! Oh, it's exactly like they're on fire!
This sudden overheating would make you nauseous. After 10 minutes, you'd be like a piece of toast. Your body temperature would hit 42 degrees Celsius, and if you've ever had a fever like that, you'd know at this point, you'd be in delirium.
I swear, there were 103 Dalmatians. Everywhere! Dalmatians everywhere!
Exactly like that.
Rico, are you a Dalmatian?
Your muscles would become weak, and your organs would start to shut down. Now you'd be unconscious, in the middle of having heat stroke and being blasted by radiation. At this point, you wouldn't have long. Hot side of Mercury rates a 2 out of 10 from me. All right, let's look at Mars. The red planet sounds a lot more promising. Where else in the solar system would you want to establish a human base? Well, not so fast. Mars sits just outside the sun's habitable zone. It doesn't have water or a magnetosphere. Its atmosphere is incredibly thin. It's not a place you could settle into comfortably.
What do you mean? Ours is great.
That is, until you try to breathe on it. On Mars, the air is mostly made up of carbon dioxide. You'd have to keep your spacesuit on at all times, because if you didn't, you'd die.
Spacesuit breach detected.
It only takes a minor suit malfunction for Mars to kill you. The first few seconds of inhaling the air on Mars would feel confusing.
What's confusing about this? I'm dying!
You'd be gasping for oxygen and starting to breathe more rapidly. At the same time, your breached spacesuit would start to decompress, and that would be truly awful. The atmospheric pressure on Mars is only 0.6% of what you have on Earth. As soon as your spacesuit gave in, all the pressure inside it, the pressure keeping you alive, would escape.
Warning. Danger of ebulism. Warning.
Ebulism is what happens next. As your suit's pressure suddenly dropped, your body would experience painful, blood-boiling conditions. You see, your blood and other bodily fluids have gases inside them. Exposed to the low-pressure environment on Mars, these gases would boil. Your skin would swell and puff up. After about 7 minutes, you'd be dead. This is going to be pretty graphic. Somebody put a warning on the screen. Mars would give you hope, and then gruesomely kill you the first chance it got. I'd seriously reconsider coming here, because even if you made absolutely sure that your spacesuit was safe and wouldn't suffer a life-ending breach, Mars will find another way to wipe you off its face. And that other way would be dust storms. Dust storms on Mars are wild. They can cover the entire planet, and they last for weeks or even months.
Can't see crap in here.
It's not that those storms are strong, they're not, but the dust particles are so fine that they get into your spacesuit easily and scratch it from the inside.
Oh man, what? Matt Damon can do this, so can I. Come on!
These fine particles would clog your air filters and do all kinds of damage to your equipment, from cutting off your life support systems to knocking out your heat regulation.
Warning. 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 Oxygen system failure.
Well, that's Mars for you. I give it a 6 out of 10 just for the epicness of this whole death situation. Oh, and for giving you a chance to live here. Just maybe not for too long.
I'd give Mars a 0.
There's one more rocky planet lurking on the outskirts of the solar system. Hold on. My editor is saying it's actually not a planet, it's a dwarf planet. Anyway, Pluto will be the last deadly place to visit on this list, right after the giants. Jupiter is the largest planet in the solar system, and as a gas giant, it has a number of ways to kill you. Being twice as massive as all the other planets in the solar system combined, Jupiter has astronomical pressure. This planet is basically a gigantic ball of hydrogen and helium. It doesn't have a solid surface you could step on. You'd fall all the way through its atmosphere, although it wouldn't be that long of a fall for you.
Let me guess. Suffocating, extreme pressure. What else is new?
Lightning. Yeah, that's right. Jupiter is home to some of the most violent lightning storms around.
Okay, well that's great, but I don't see any here.
Well, of course not. In the upper atmosphere, the weather is not as dramatic. The atmospheric pressure here is only 1/10 of the pressure we feel on Earth.
Capsule systems are stable.
Some 50 kilometers below Jupiter's clouds, you'd feel serious turbulence. Wind here would be strong, reaching up to 360 kilometers per hour.
Static buildup detected in the atmosphere.
As these chaotic winds violently battered you through the storm clouds, the lightning bolts would strike too close for comfort. The atmosphere around you would be highly charged. And then one of these bolts would strike the capsule head on. This massive lightning would release enough energy to power a city or two. But for your capsule, it would be game over. The electrical systems would fail, the oxygen supply would fail, and the temperature inside the capsule would drop significantly. You'd now be trapped inside a powerless, leaking capsule surrounded by a deadly storm. I give Jupiter a 5 out of 10. Could recommend. This gas giant may not be as large as Jupiter, but it's definitely the most majestic. Saturn is the second largest planet in the solar system, and just like Jupiter, it's a gas giant made up of hydrogen and helium with no solid surface. Deep down in its clouds, the unimaginable pressure of this world turns hydrogen into liquid metal. And intense storms have winds raging at 1,800 kilometers per hour. It's windy, it's hot, it's dangerous. And you might die before you even enter Saturn's atmosphere. What makes Saturn the most marvelous planet in this planetary hood is also what makes it dangerous on approach. Saturn's rings.
Yeah. Okay, yeah, I see them all right.
These rings are made up of billions of small chunks of ice and rock, ranging from grains of dust to icy chunks the size of a house. Saturn has had its rings for a few 100 million years, and it'll have them for the next few 100 million years until these icy rocks rain down on the gas giant. The thing is, these rings move extremely fast, like 70,000 kilometers per hour fast. If you're not careful, your ship might just crash into them. Saturn gets an 8 out of 10. Uranus is a beautiful, stormy, fart-smelling, deadly ice giant. It has the coldest atmosphere of all the planets in the solar system. And it can kill you in many ways. One way to go on Uranus would be to suffocate in its gases.
Oh, not the fart gases!
Close enough. 2% of the Uranian atmosphere is methane, a gas that's toxic to humans. Now, 2% might not sound like a whole lot, but it's concentrated enough to kill you within minutes. Maybe Uranian high-speed particles moving at 900 kilometers per hour eroded your suit. Or extreme temperatures of minus 224 degrees Celsius made it brittle and caused it to crack. Or hydrogen and methane had a chemical reaction with your suit materials, corroding them. On Uranus, anything could cause a breach, and even the smallest breach would lead to toxic methane exposure. But Uranus has other surprising ways to off you, like turning you into a human-sized diamond. You'd have to survive the trip deeper into Uranus to be turned into a diamond, all the way to some 10,000 kilometers below its cloud tops. That's where the pressure is so intense and the temperature is so high that carbon atoms crystallize into diamonds. About 18% of the human body is carbon, so you'd be about to undergo the most precious change of your lifetime. I'd give Uranus a 10 out of 10. Epic, sparkling, with a bit of fun. Great planet to perish on. Now, this is the last ice giant in the solar system and the most distant planet from the Sun, Neptune.
Huh. Neptune, it looks a lot like Uranus.
It's true. Neptune has a similar mass and size as Uranus, and it's even made up of some of the same materials like hydrogen, helium, iced ammonia, methane, and water. Only Neptune has one thing Uranus does not.
Extreme winds detected.
Neptune has the fastest winds in the entire solar system. These gusts reach speeds of 2,100 kilometers per hour. They're not just winds, they're supersonic winds.
Hey, nobody told me that we were filming a Top Gun sequel in here, okay?
It gets worse, too. Not only are these winds extremely fast, but they're also turbulent. They create swirling vortices that would throw your spaceship in different directions. Intense atmospheric pressure, winds, and methane ice would start ripping the ship apart. But that's not all. If you got caught in the Neptunian supersonic vortex, the winds would violently spin the ship, and this centrifugal force would exert some serious G-forces. As Neptune's winds accelerated your ship to about 10 Gs, everything inside your body would feel heavy. That would be your organs getting compressed inside your body. Your blood would pool around your legs and cause oxygen deprivation to your brain. You'd lose consciousness pretty quickly. It would only take about 5 minutes for the ship and your body to lose their structural integrity completely and disintegrate into the Neptunian atmosphere. Well, that was pretty violent. I give Neptune a 2 out of 10.
Well, I know you guys like Pluto, so since you asked so nicely, I thought I'd give you a little treat and show you what it's like here.
Pluto isn't exactly a planet. It's a dwarf planet on the outskirts of the solar system. It's smaller than Earth's moon, but even this tiny rock has ways to kill you.
It's a little cold in here, you feel that?
Temperature reading, minus 239 degrees Celsius.
Pluto is even further away from the sun than Neptune, so it barely gets any of the sun's energy. One small malfunction in your spacesuit insulation, and you'd freeze to death. You'd feel the frostbite setting in after just 30 seconds. Another 30 seconds later, your bodily fluids would start turning into icicles, and you'd get extreme hypothermia as an unpleasant bonus that you didn't ask for. After 2 minutes, your body temperature would drop below 30 degrees Celsius, which is the exact moment when you'd lose consciousness. After 3 minutes, your body would freeze and your organs would fail. You'd become one with Pluto's frozen landscape. Quick and almost painless. That's a 7 out of 10 for Pluto.
It did hurt.
Well, that's it for this solar system's planets. Where should we send Chase to where should we send Chase to explore next? Maybe we'll ship him all the way to an exoplanet outside of our planetary corner. But that's a story for another What If. Support us on Patreon and help us send Chase to his next adventure. Thanks, Space Explorers. That was pretty violent. I give... What planet are we on? Chase is dead? Okay. That one was a lot of fun for me. Multiple Chase deaths in a single episode makes me very happy. Okay, now for the fun stuff. Let's put the rest of these videos in order, chronological order, from our first What If hits to our most recent What If hits. This first one was one of our first real hits, written back in 2019 by Kevin Kalachi. This is our second most watched video of all time, closing in on 18 million views on the YouTube. Now, we didn't see the host of What If in the videos back in those days, but see if you can guess who it is.
A volcano is one of the most unforgiving natural phenomenons on Earth. If you were to fall into its magma-filled center, your body would quickly bubble up and disappear without a trace. So, if they're so good at getting rid of things, has anyone tried it before? How would we transport all our trash to them? And what dangers would be involved? This is What If, And here's what would happen if we dumped our trash into volcanoes. Americans alone generate about 254 million tons of trash per year. And although dumping it into volcanoes might sound like the perfect way to get rid of it, it wouldn't be that easy. Volcanoes might look like nature's garbage incinerators, but in reality, they're much more dangerous and unstable. Not to mention, a lot harder to get to. Would overcoming these obstacles be worth it? Or would dumping our trash in volcanoes just cause even more harm to our planet? The first obstacle in our quest for volcanic garbage disposal would be finding an active volcano that can get the job done. There are only about 1,500 potentially active volcanoes worldwide, and most of them aren't located anywhere near humans, for obvious reasons. That means getting all our trash to an active volcano could turn out to be pretty expensive. And once we get there, we might find out it's not even the right kind of active volcano. The kind of volcano we'd be looking for is called a shield volcano, a slow erupting variety that contains the iconic lava lakes that gradually spew out onto the Earth. Unfortunately, these aren't very common. You're more likely to come across their angry cousins, known as stratovolcanoes. Stratovolcanoes are known for their explosive eruptions, caused by the buildup of pressure from hot gas and magma. In other words, they're probably not the safest location for the town dump. But let's say we're lucky enough to find ourselves a nice active shield volcano. Before we worry about the logistics of getting our trash there, if you were one of the first waste collectors hired to drive up to the vent of a volcano, you'd quickly start to question your career choices. The vent of a volcano is a treacherous environment full of poisonous gases, lava splatter, and projectile rocks. And things only get worse once you start throwing stuff inside. In 2002, a group of Ethiopian researchers threw a 30-kilogram bag of trash into a volcano, and the results were explosive. Lava lakes are unstable, so if you pierce their surfaces with something cold like trash, you'll trigger a chain reaction of explosions involving pressurized and acidic steam. So can you imagine how big these explosions would be if you threw an entire nation's trash in there? Well, to put it in perspective, rock falls into lava lakes in Hawaii have sent lava 85 meters into the air, so it'd probably look something like that. Even if you could safely get your trash into the volcano, you'd still have to worry about all the air pollution created by burning our waste without filters. Plus, not all materials will completely break down in lava, which means that the polluting remnants could erupt out and contaminate the surrounding landscape. Not ideal if you were hoping to burn nuclear waste, for example. Add these environmental impacts on top of the fact that shipping all our trash to these volcanoes would significantly increase the carbon footprint of the waste disposal, and the whole thing looks like a terrible idea. If we're going to burn our trash, why not at least do it someplace where we can use the heat released through incineration to create new sources of energy?
Something is lurking in the water. Do you see it? Close calls like this happen with whales more often than you might expect. And although the people in these videos got away relatively unscathed, there's no denying that they were just meters away from being a whale's lunch. But what would happen if they hadn't been so lucky? Could a human body survive being swallowed by a whale? Has it ever happened before? This is What If, and here's what would happen if you were swallowed by a whale. If you've never seen a whale up close, it's hard to comprehend just how monstrous they can really be. To put it in perspective, the blue whale is the largest animal on the planet. Its tongue alone weighs as much as an elephant, and it can fit anywhere between 400 and 500 people in its mouth. But we wouldn't have to worry about one of these guys swallowing us anytime soon, because their anatomy makes it nearly impossible. Instead, we should be more concerned with their smaller cousins, sperm whales. In 1891, reports emerged that a man had been swallowed by one of these whales. And although he lived to tell the tale, he would never be the same again. According to the story, James Bartley was swallowed when a whale attacked his ship, and he wasn't retrieved until the following day. When the crew found and killed the whale, they quickly brought it on board their ship and cut it open, revealing an unconscious but very alive James Bartley. His face and arms were bleached white, and he was blind, all thanks to the stomach acids of the whale. However, as the years went by, people started poking holes in this story and questioned whether James had really been swallowed by a whale. I mean, wouldn't the stomach acids do more damage than just bleaching his skin? Well, with the power of science, we took a closer look, and we quickly discovered that if you get swallowed by a whale, coming back out with shiny white skin would be the least of your worries. Okay, so the first thing you'd have to worry about once you were swallowed would be getting shredded to pieces by the sperm whale's impressive set of teeth. Each tooth is approximately 20 centimeters long. That's about the length of an average chef knife, and whales have anywhere from 40 to 50 of these. Let's say you're lucky enough to make it past all of them. Next, you'd begin your descent down the throat. Not only would it be dark and slimy down here, but you'd also find it hard to breathe due to the lack of oxygen and an increase in methane gas. As the whale's throat muscles constricted in and out to help force you down, you'd also start to feel hydrochloric acid beginning to eat away at your skin. I know what you're thinking. We just got into this whale and James Bartley's story already seems pretty fishy. Well, you're not wrong, but what would be the fun in stopping now? So next, you'd be dropped into the first and largest of the whale's 4 stomachs. You'd probably be in there for a while, but on the bright side, you might have some light in the form of a bioluminescent squid or two being noshed on after your arrival. Sperm whales love neon flying squid. You'd better enjoy this brief light show because after this, you'd just be tossed from one stomach to the next, with the acids breaking down almost all of your body until you're just a bunch of bones being unceremoniously ejected from the whale's anus. So yeah, it's pretty safe to say that there's no way you could be swallowed whole by a whale and live to tell the tale. Sorry, James, you may have been able to fool people in the 1890s, but we're onto you now. As vast as they are and as monstrous as they might seem to us, whales actually have no interest in eating humans. And if they could talk, they would probably make a point of telling us that.
Imagine if all the Earth's oxygen disappeared. Not forever, just for say, 5 seconds. Would we just hold our breath? What would happen to the atmosphere? What would happen to the environment? This is What If, and here's what would happen if the world lost oxygen for just 5 seconds. Take a nice deep breath. Feel how satisfying that is? What you're breathing in is oxygen, and it takes up roughly 21% of our atmosphere, with 78% being nitrogen. Although it's not the most abundant gas in our atmosphere, it is the most important. Without oxygen, plants, animals, water, and us humans wouldn't be where we are today. 5 seconds may not sound like a whole lot of time to be without oxygen. Most of us can go at least 30 seconds without taking a breath, so it would happen too fast for your body to even notice. Your breathing would actually remain normal, but as for everything else, not so much. In just 5 seconds, the Earth would look completely different. Without oxygen, you can say goodbye to the Hoover Dam, the Pantheon Dome, and anything else made of concrete. These structures would instantly collapse. Oxygen acts as a special binding agent to concrete. Without it, concrete is just dust. Speaking of buildings, any untreated metal would instantly be fused together. This is because there's a layer of oxidation on metals that prevents them from welding together. Without that layer, metals would instantly bind to each other. If you happen to be relaxing at the beach at the time, expect a severe sunburn. The ozone layer, our protection against the sun's UV rays, is made of oxygen. Take away the oxygen and the Earth would become extremely dangerous. There would be nothing protecting us from the sun's UV rays. In addition to a sunburn, our inner ear would explode. Losing oxygen means losing 21% of our air pressure. A change in air pressure that drastic is equivalent to being at sea level and dropping down 2,000 meters instantly. our ears wouldn't have enough time to adapt. Having a good time yet? Well, don't expect it to last long. Without oxygen, there's no fire. The combustion process in vehicles wouldn't be able to occur. Any mode of transport that isn't electric will automatically fail. Planes will fall from the sky, and millions of cars will be stopped in their tracks. The sky would be completely dark. Before it hits the Earth, light from the sun bounces off multiple particles in the air. Without oxygen in the atmosphere, there are less things to bounce off, and the sky will appear dark. Oh yeah, and while all this is happening, the Earth's crust would completely crumble. That's because Earth's crust is made up of 45% oxygen. The crust would crumble and continue to crumble until there's nothing left, sending you and everyone on the planet into a free fall. Sound like fun? Probably not. But luckily, you can take a deep breath of 21% oxygen knowing this will never happen.
So, did you guess who the voice on those videos is? Yeah, I think you know. I've been the voice on this channel since the beginning, back in 2018. That's actually when that story about losing oxygen was written. I gotta admit, I've changed a lot over the years, at least my voice has. That voice sounded like it was on 1.5 speed. Sounded like all the oxygen disappeared and I was breathing helium. Embarrassing. Oh well, it's only been seen by 14.5 million people. What are you gonna do? Here's another one of our favorites, and obviously one of your favorites too, seeing as it's been seen 13.7 million times. This one was written before we even had a YouTube channel, back when we were only available on that Mark Zuckerberg platform. And fun fact, it was written by a young woman named Marina Hordienko, who has since gone on to be the senior producer of What If. Same idiot voicing though.
How much do you know about black holes? What would happen if you fell into one? Say one day you were exploring space, looking for a new planet for humans to inhabit, but came across a black hole and decided, why not check it out? Would you have any chance of survival? How would you get out? Would there be a shortcut to another universe? This is What If, and here's what would happen if you fell into a black hole. Despite being black and a black hole is not a dark, empty space. In his theory of relativity, Einstein predicted how black holes are formed. When a massive star dies, it leaves a smaller, remnant core behind. If the core's mass is at least 3 times bigger than the mass of our Sun, gravity overwhelms all other forces and turns the core into a black hole. But don't let its name fool you. A black hole isn't a hole at all, but rather a huge amount of matter packed into a very small space. Think of the Sun, with its gravitational field 28 times stronger than Earth's. If you were to walk on the Sun, you'd be 28 times heavier than you are on Earth. Now imagine squeezing 4 suns into something that's just 15 miles in diameter, the distance you can cover in a 30-minute drive. What would the gravity be like there? A black hole's gravity is so strong that even light can't get out. That's why you'll never see one, but you can detect it from the gamma ray bursts that the hole emits. These bursts, discovered by Stephen Hawking, now carry his name, Hawking radiation. Stephen Hawking himself believed that black holes can be passages to another universe. So, if you were to fall into one, would you find yourself in an alternate dimension? Every black hole has an event horizon, the point at which gravitational pull becomes so strong you can't escape from it. The point of no return. If you found yourself outside of that point, you'd see that stars are twisted around a perfect circle of darkness. As you start being pulled toward a black hole, you'd be moving faster and faster, accelerated by the force of gravity. That's the first bad news for you, brave space traveler. The gravitational force of a black hole is very, very strong. If you fell feet first, your legs would be feeling a stronger gravitational pull than your head. Your body would be stretched apart. The most common black holes are called stellar. They can stretch about 9 miles across and be as heavy as 20 suns. If you happen to be pulled towards a stellar black hole, you'd be completely torn apart before you even reach the event horizon. So make sure to choose a supermassive one, the one that's 1,000,000 times heavier than our Sun. In this case, your body would remain unharmed as you cross the event horizon, as the gravity would be pulling both your feet and your head with almost the same strength. And if you're wondering where to find one, you don't have to look too far. There's one right at the center of our Milky Way galaxy. Luckily, it's 165 quadrillion miles away from us and will suck in neither the sun nor the planets. But don't pack your suitcase just yet. Crossing the event horizon is just the beginning of the challenge. There's a gravitational singularity at the center of the black hole, where density becomes infinite. You'd be squashed into that center and become one with the black hole. You wouldn't be able to tell anyone about your experience. However, a person observing you from outside the event horizon would see a very different picture. As you were falling into a black hole, they'd see you slowing down, getting dimmer and redder. In the end, you'd just freeze, never crossing the event horizon. This is because space and time in a black hole swap their roles. At the event horizon, time comes to a standstill, while space, on the other hand, moves forward. You wouldn't be able to turn around and escape the black hole any more than you could travel back in time. Even when the black hole eventually died, emitting all the particles it had absorbed, including your body, it would be impossible to tell whether those particles were you. Stephen Hawking, however, found a way in which the information about your body wouldn't be lost. He theorized that there are alternative universes with different histories. This means in one reality you fell into a black hole. In the second one, there was no black hole. It's impossible to be certain from outside of the event horizon whether there's a black hole or not until you fall in there. If you cross the event horizon and there was a black hole, sayonara. But if you happen to be in a reality where the black hole didn't exist, you'd still be alive, just in a different universe. There would be no way for you to get back to ours. Would you dare explore the possibility?
Have you ever heard of Medusa? The snake-haired Greek monster who turns people to stone with a single glance? Well, she may just be a myth, but there is an area so deadly that it could actually turn you to stone. The infamous Lake Natron. What makes Lake Natron's water so dangerous? What kind of creatures live there? And could you survive if you fell in? This is What If, and here's what would happen if you jumped into Lake Natron. Before we take the plunge, we'd better look at what Lake Natron is made of. Much like the Dead Sea, this Tanzanian lake doesn't run off into any oceans or rivers. This allows it to soak up all that salty desert rain. Soupy. Yet, what makes it especially lethal is its close proximity to the active volcano Oldoinho Lengai. The volcano spews a rare kind of lava, rich in sodium and potassium carbonate, called natrocarbonatite, or natron for short. Releasing into the water, this mix of sodium carbonate and sodium bicarbonate were key ingredients once used in Egyptian mummification, creating the perfect preservative in lake form. The whole chemical composition is extremely alkaline, with pH levels of 10.5, close to that of ammonia. This gives the lake its rosy hue. Any birds who happen to take a dive and don't make it out become calcified in a hardened stone-like husk. Oof. Talk about killing two birds with one stone. In 2013, wildlife photographer Nick Brandt was one of the first to document this phenomenon. He discovered several stone birds and other unlucky animals in the dry season when the water had receded. He theorized that since the lake is so mirror-like and reflective, the birds must have flown right into it, as if it was a big glass door. But despite so many birds dying in Lake Natron, there is a particular species flourishing. Turns out, the lake's toxic waters provide a safe haven from predators, making it perfect flamingo flocking grounds. So, if flamingos can handle it, couldn't we? Well, it's not that simple, unfortunately. Flamingos thrive in salty lakes because of their tough skin and scaly legs, which prevent burns. They can drink the fresh water from nearby springs or geysers at the edges of the lake, and if they're desperate enough, they can even filter salt water with special glands in their nasal cavities. And to top it all off, Their strong stomachs allow them to feed on the toxic algae found throughout the lake. This makes Lake Natron the perfect spot to raise and protect their young. So let's say we tried to live like a flamingo and decided to take a dip. Well, depending on the time of year, the water can be up to 60 degrees, which is hot enough to cause third-degree burns in 5 seconds or less. Also, I wouldn't plan on doing any fancy dives or cannonballs, as its shallowness is also chock full of sharp, salty structures. You wouldn't be turned to stone instantly, but if you happened to drown and stay submerged, your entire body would harden and be preserved. If people found you hundreds of years later, you might still have your hair and organs intact. Yeah, still looking spiffy after all those years. Like mummification, natron's super high alkalinity stops the decomposition process. Thankfully, this means you'd be safe from vultures or any other hungry scavengers looking for a snack. If you waded into the lake at a time when the water temperature was lower, it could feel more like a hot tub. But your eyes or any open wounds would sting like crazy because of all that salt. I'd strap on some goggles if I were you. In 2007, another bird flew straight into this chemical cocktail. A group of wildlife videographers plunged into Lake Natron's toxicity when their helicopter crashed. The pilot suffered a broken leg and another passenger had a broken hip. Incredibly, one of the passengers managed to struggle to shore and alerted some of the Maasai tribespeople nearby. They quickly built stretchers and carried the injured to land in the nick of time. Even though you could survive Lake Natron's waters, I'd stick to a swimming pool if I were you. As for our flamingo friends, this just goes to show how the harshest environments can be a sanctuary for some animals. But if you're craving something even more extreme, what you're seeing isn't a watercolor painting in motion. In fact, it's the planet Jupiter. For the most part, this gas giant is a mystery. So what would happen if you wanted to discover it for yourself and jumped right onto the planet? Or should we say into, because Jupiter doesn't have a surface, just a seemingly endless stretch of atmosphere. Would you fall straight through? What would you see on your way? And how would it make you feel? This is What If, and here's what would happen if you fell into Jupiter. If you attempted to jump into Jupiter wearing a standard spacesuit, it'd be over for you pretty quickly. First of all, you wouldn't even make it to the planet. Roughly 300,000 kilometers from Jupiter, radiation would penetrate your suit and you'd die. But that's a boring what if. We'll give you a special spacesuit that can survive the fall, for now. Here's where the real fun begins. At first, you'll be falling from the top of the atmosphere at nearly 180,000 kilometers per hour. That's a lot faster than you'd fall from the top of Earth's atmosphere because Jupiter's gravity is much stronger than Earth's. You'd still be able to see the sun, but don't expect it to heat you up. At about 250 kilometers down, you'd reach the ammonia clouds and experience temperatures of minus 150 degrees. Now, get ready for the most epic whirlpool of your life. Jupiter's clouds create powerful winds, up to 482 kilometers per hour. You'd feel as if you were in one giant, colorful tornado. That's because Jupiter is the fastest rotating planet in our solar system. One day on the planet is equal to 9.5 Earth hours. Let's go down about 120 kilometers more. Congratulations, this is the deepest that any exploration has ever sailed into the gas giant. In 1995, NASA's Galileo probe made it this far before it was destroyed by the pressure of Jupiter's atmosphere. But don't worry, that's not happening to you. You've got the suit. The further you travel, the darker it will get, until it's completely pitch black. The only source of light you'll have will be from the lightning storms happening all around you. At this point, the temperature will start to increase, and it might even feel comfortable if it weren't for the immense physical pressure you'll be feeling. The pressure you'd experience is more than 1,000 times higher than on the surface of the Earth.
The only way you'll be able to survive is if your spacesuit was built as strong as the deepest diving submarine of all time. By now, you've been falling for 12 hours, and let's be honest, you're getting a little bored. You'd probably want to radio someone to come and get you. Well, that's too bad. That's an impossibility inside Jupiter, since radio waves get absorbed this deep into the planet's atmosphere. You'll just have to keep falling. The temperature will keep rising, and so will the pressure. As you reach the inner layers of Jupiter, there'll be parts that you'll be able to swim through. A substance that's not quite liquid or gas, known as supercritical fluid. Moving through this strange material, the temperature will get even hotter. Eventually, it will be equivalent to the surface of the sun. If that isn't enough, you'll also be experiencing pressure equal to 2 million times the pressure on Earth. Metallic hydrogen will begin to form, and you'll be surrounded by it. This relatively unknown substance can be a dense liquid that you won't be able to escape from. If you do manage to escape, you'd be falling through it for thousands of kilometers until you reach Jupiter's core, possibly a solid object. Some scientists predict it is, due to the immense pressure at this level in the planet. Regardless of what it is, if you somehow did manage to survive all this, you'd be stuck on it from all the atmospheric pressure. Not a very rewarding trip. Maybe we should leave the planet as a beautiful mystery. But if you do ever manage to fall into Jupiter and get stuck, let's hope you have a few more what-if videos to keep you company.
This is What If. And here's what would happen if the sun exploded tomorrow. That star at the center of our solar system, that super hot ball of plasma that gives us heat and energy, and amazing complexions. Well, it's a ticking time bomb. The sun is about 10 billion years old, but it's only expected to last about another 5 billion years. After that, the sun will expand, becoming a red giant. Then, it will shrink to become a white dwarf, a dying star, cooling for the next several billion years. Of course, we'll all be long gone before any of that happens, but still, can you imagine what it would be like to watch the sun blow up before your very eyes? With a name like supernova, you'd think that a solar explosion would be the most magnificent fireworks show the world has ever seen. But in reality, you likely wouldn't see anything. The sun is 150 million kilometers away from Earth, and it takes 8 minutes for light from the sun to reach us. And while that may seem super far away, in supernova terms, we don't stand a chance. For Earth to be completely safe from a supernova, we'd need to be at least 50 to 100 light years away. But the good news is that if the sun were to explode tomorrow, the resulting shockwave wouldn't be strong enough to destroy the whole Earth. Only the side facing the sun would boil away instantly. The lucky other half would experience a rise in temperature that would be 15 times hotter than the sun's current surface temperature, and permanent darkness. And without the sun's mass keeping us in orbit, Earth would likely start floating off into space, while its remaining inhabitants desperately struggle to stay alive. There is a chance that our planet could lock into orbit around another star that might provide the same light and heat as our sun, but by the time that happened, we'd all be long gone. If we knew in advance the day that the sun would explode, then we could buy ourselves as many as 1,000 years of time, provided we had the resources to sustain ourselves for that long. And we could. Just a few meters below the ground you walk on, the Earth is maintaining a temperature of about 17 degrees. So if we had enough time to prepare, civilization could continue to live by moving underground into a huge network of fortified bunkers. Within a week after the explosion, the surface temperature on Earth would drop to minus 18 degrees. Within a year, temperatures would plummet to about minus 73 degrees. At this point, the oceans would begin to freeze from the top down. Within 1,000 years, Earth's atmosphere would freeze and collapse, leaving anything left on the surface exposed to cosmic radiation and meteor impacts. Hopefully, by that point, we'd have found ourselves a new home. The good news is that if the sun were to explode, and it will eventually happen, it wouldn't happen overnight. When the sun does die, it will be a long, slow, arduous process taking place over billions of years. The sun will get hotter and brighter, and it will start to expand. During this process, it will lose its outer layers to the cosmos, leading to the creation of other stars and planets, in the same way that the violent burst of the Big Bang created Earth. Who knows? Maybe new life could form. Can you imagine another Earth? A new humanoid species? It's hard to predict how our galaxy might look billions of years from now, and it's especially hard to imagine our solar system without the great golden anchor that keeps us all together. But one day, in the very, very distant future, the sun will expand, and then it will shrink, maybe leaving room for a new star to take its place. And if by some miracle humanity still exists at that point, where might we be living?
Okay, that was a little more like it. The guy voicing that video gets it. Reminder, it's me. That one was from 2019, pretty much exactly 6 years ago, and it's amassed 11 million views on YouTube. Nice. Finally got the tagline right around that time, too. Before that, it was like, for more fun things to speculate on, keep checking back with the show What If? Or, that's a topic for another episode of What If? But this next one has got over 10 million views, and it let us know loud and clear that this beast was going to be a What If superstar. You guys can't get enough of it and keep asking for more. Well, here's our first video about the Megalodon.
Would you ever venture in the ocean if you knew this creature could be lurking beneath you? It's twice the size of a T-Rex. Its jaws are big enough to crush cars. And it can swallow multiple humans at a time. This ancient beast is called a Megalodon shark. And if it had never become extinct, it would have a surprisingly large impact on our lives. How would it change the way we use our oceans? How big of a threat would it pose to people? And what are the chances that these creatures have been hiding deep in our oceans all this time? This is What If, and here's what would happen if Megalodon sharks had never become extinct. Over the years, reports of Megalodon sightings have emerged all over the internet. A lot of them claim that these giant sharks never went extinct, that they've just been hiding in the deepest part of the ocean, the Mariana Trench. Now, you can't dive down there to check for yourself, but scientists say there's more than enough evidence to debunk these online accounts. If Megalodon sharks were still around, we'd definitely know about it by now. Our oceans would be a lot more dangerous. Here's how we know that Megalodon sharks haven't been hiding from us this whole time. For starters, if Megalodon sharks still roamed our oceans, the last place they'd be going would be the Mariana Trench. Megalodons were warm water mammals, so the frigid temperatures of the Mariana Trench would make it impossible for them to survive there. Plus, if these enormous sharks still existed, we'd be finding their signature giant bite marks on other large marine animals. We'd also most likely have found at least one carcass or skeleton by now, but that hasn't happened. The only remnants we've found of these prehistoric monsters are their teeth and we've found a lot of them. The reason megalodon teeth are so easy to find is because they produced a ton of them. Unlike humans who only produce teeth during the early stages of life, sharks continue to produce new sets throughout their entire lives, losing their teeth almost every 2 weeks. Their teeth would sink down to the bottom of the ocean where they would likely be fossilized. Most megalodons would go through about 40,000 teeth in their lifetime. That's a lot of remains for us to discover. But because we've never found an intact megalodon, there's still a lot we don't know about them. Here's what we've been able to find out so far. Megalodon sharks first showed up about 16 million years ago, and they were a dominant predator in the ocean. Measuring anywhere between 10 to 18 meters, these giant beasts preyed upon anything from fish to dolphins and even whales. Then, about 2 million years ago, they disappeared off the face of the Earth, and scientists aren't exactly sure why. One theory is that they became extinct due to decreasing food sources and increasing competition for that food. Another, more intriguing theory is that megalodons simply couldn't adapt to the cooling ocean temperatures, and that their prey kept moving to colder waters to escape them. Regardless of the reason behind their extinction, you can't help but imagine how different our oceans would be today if they had survived. It's estimated that a megalodon ate about 1,100 kilograms of food each day. If they were still around and eating that much, then there'd barely be enough large fish left in the ocean for us. And that wouldn't be the only problem for the fishing industry. We could also see megalodons tracking fishing boats and stealing the fish they catch, just like some killer whales do. With ocean temperatures warming up again, megalodons would be thriving and reproducing, resulting in even more of these giant mammals in the water. That would spell trouble for maritime shipping operations, cruise ships, and even beachgoers. Megalodons gave birth in warm, shallow waters, so a nice recreational beach swim could become very dangerous for us.
It's been 30 days since Uranus first appeared in the sky. At first, it looked like our moon had found itself a stellar partner. But then we understood something much, much bigger was headed our way. What caused Uranus to become so unstable? How could this epic collision change the ice giant? Oh, and what's this horrific stink? Ugh! This is What If, and here's what would happen if Uranus collided with Earth. Let's roll back 30 days, when things were still normal. Uranus lived a quiet life on the outskirts of our solar system, about 3 billion kilometers away from us. And then suddenly, it began to move closer. Astronomers would be the first to push the panic button. By their calculations, it would take Uranus 13 years to reach the collision point. We'd be short on time, but at least we'd have a slight chance to evacuate the Earth. But the cold blue giant had other plans in mind. This would be no standard planetary drill. Planets don't just take off from their orbits for no reason at all, but somehow Uranus did. Now it would be hurtling through the solar system, ramping up to a speed of around 1,000 kilometers per second. Because of this unexpectedly fast speed, we'd only have about 30 days left on this planet. Uranus would shine like a bright blue star in the sky, and every day it would appear bigger and brighter. Our sky would look gorgeous, not only because of the ice giant shining down on us, but also thanks to many shooting stars. Only those wouldn't be stars at all. To get to the Earth's orbit,
Uranus would have to pass an asteroid belt between Jupiter and Mars. This would disrupt the stable orbits of many asteroids and throw some of them our way. These asteroids can be as big as 240 kilometers in diameter. That's a few times larger than the one responsible for wiping dinosaurs off the face of the Earth about 65 million years ago. We would have nowhere to go. We'd just be left here, watching the end of times unfold in front of our eyes. Might as well enjoy the view. By the time the first asteroids appeared as shooting stars, Uranus would look about the same size as the Moon, but it would be growing rapidly as it moved ever closer. While you'd be here awaiting humanity's doom, Uranus would start shaking things up. Because Uranus is about 15 times more massive than the Earth, its gravitational pull would start massively affecting our planet. Volcanoes would begin erupting uncontrollably, and tremendous earthquakes would get in on the act, destroying the Earth from the inside. And the stink. You'd drop unconscious from even one whiff of it because, well, Uranus smells like farts. The ice giant's upper atmosphere is mostly composed of hydrogen sulfide. It's the same stuff that makes rotten eggs reek so bad. Imagine an entire planet of rotten eggs engulfing the Earth. Blech. The thought of it makes me nauseous. But Uranus wouldn't come alone. It would bring all of its 27 moons along for the ride. And those moons would be hitting the Earth from all sides. As a fart-filled finale, Uranus would compress what was left of our atmosphere, and the rapidly rising temperatures would ignite it. Just like that, our beautiful blue planet would fall in line and start circling the ice giant, eventually becoming one of its many moons. Uranus wouldn't get away with this assault so easily, however. Last time it collided with another planetary object twice the size of Earth, it tipped over. Yeah, Uranus is the only planet in our neighborhood that spins on its side. This impact, featuring our earthly home, could help tilt it back to how it once was. But for the Earth, we know that would be it. If by some unexplained mystery, life on Earth's stinking leftovers emerged once again, we would see the blue of Uranus on the horizon. If you traveled 10,000 years into the future, what would planet Earth look like? Would most of its surface be covered in volcanoes? Or would it be frozen in ice? What if you traveled even further, to 1 million years in the future? Would all of the oceans have evaporated? Or would it have become one giant water world? Okay, now, what about 1 billion years? Would there be any humans left? Or would they have settled in other parts of the galaxy? This is What If, and here's what would happen if you traveled 1 billion years into the future. Let's face it, the chances of any humans being around to greet you when you arrive 1 billion years into the future are pretty low. Several key existential threats face the human race, and if we want to be around in 1 billion years, we'll need to endure them all. We've seen how much we've struggled to come together just to survive a global pandemic. So how do we have any chance of enduring the threats of climate change, overpopulation, global nuclear war, killer asteroids and comets, natural ice ages, and the sun getting a whole lot hotter? Well, let's take a look into the future and find out. Just under 10,000 years from now, we're going to run into a big problem called the Deca-millennium bug. In the year 10,000 AD, software encoding the AD calendar year won't encode dates with more than 4 decimals. Remember Y2K? Yeah, it's just like that, except hopefully we won't panic as much this time around. On the bright side, in 10,000 years, genetic differences and traits between humans will no longer be regional. Traits like skin and hair color will be evenly distributed around the world. Maybe that will help us all get along. Finally. 20,000 years into the future, none of the current languages will be recognizable. Future languages will only contain 1% of the core vocabulary words of their present-day counterparts. 50,000 years from now will mark a new glacial period for the Earth, which will start a new ice age. Niagara Falls will have eroded into Lake Erie completely. And, interestingly, a full day on Earth will also increase by 1 second at this point in time. So much more time for activities. In 250,000 years, the Loihi volcano will rise above the water to form a new island in Hawaii. And in 500,000 years, it's likely that an asteroid with a diameter greater than 1 kilometer will hit Earth, unless we can prevent it. The resulting crater will be no less than 400 kilometers across. It will start fires all over the planet and make the air unbreathable. So there's something to look forward to. And in case that's not enough, in 1 million years, we'll likely have another supervolcano eruption, large enough to spew out 3,200 cubic kilometers of ash. It would produce enough lava to fill 75% of the Grand Canyon. This would be similar to the Toba eruption that almost wiped out humanity 70,000 years ago. Oh, and the nearby star Betelgeuse will have exploded into a supernova by this time, making it visible from Earth even during the daytime. In 2 million AD, humanity will have settlements throughout the solar system. This also means that if populations on different planets have remained separate, humans may have evolved into other species adapted to their specific world. In 10 million years, a huge part of Eastern Africa will break off, forming a new ocean basin. In 50 million years, Africa will collide with Eurasia, closing off the Mediterranean Sea, and a new mountain range will form between the two land masses. This mountain range may include a mountain taller than Mount Everest. Out in space, Mars will collide with its moon, resulting in it developing a ring system like Saturn's. In 60 million years, the Canadian and American Rockies will have eroded entirely. In 80 million years, all Hawaiian Islands will be below the water. In 100 million years, an asteroid similar to the one that killed the dinosaurs 66 million years ago will likely hit Earth, one that is 10 kilometers wide. In 250 million years, all of Earth's continents will be fused together like Pangea, except this time it will be called Pangea Ultima. But don't get too attached to it, because in 400 to 500 million years, Pangea Ultima will separate again. In 500 to 600 million years, a gamma ray burst will likely occur within 6,500 light years from Earth. If it strikes Earth, it could damage the ozone layer and trigger a mass extinction. 600 million years from now, the moon will be so far from Earth that total solar eclipses will no longer be possible. And the sun's increasing luminosity will have raised temperatures on Earth so much that it could halt plate tectonics movement. In 800 million years, carbon dioxide levels will drop dramatically and photosynthesis will no longer be possible. Free oxygen and ozone will disappear from the atmosphere, and complex life on Earth will die. And finally, in 1 billion years, the sun's luminosity will have increased by 10%, and the average temperature on Earth will be 47 degrees Celsius. Our atmosphere will feel like a damp greenhouse, and our oceans will evaporate, leaving just pockets of water at each of the poles. When you arrive here in your time machine, be mentally prepared to take in a planet Earth that looks nothing like the one you remember. The human race will be gone, hopefully living its best life on some other far-off planet. Because of the intense heat, lack of water, and lack of breathable air, Earth will be uninhabitable. So you probably shouldn't stay too long. Instead, you should head out to see the rest of the solar system. Could a black hole devour us all one day? There are millions of them out there, just waiting. And if we happened to make a black hole accidentally, well, you better fasten your seatbelts. Things are really going to suck. Literally. What would we see if we got pulled into a black hole? Could Earth orbit the sun and a black hole? And would we survive spaghettification? This is What If, and here's what would happen if Earth were sucked into a black hole. Just 3,000 light years from Earth is a black hole visible to the naked eye. Thankfully, we're a safe distance from this stellar black hole and many others like it. There are approximately 100 million of them out there in our galaxy that we know of. They are remnants of supernovae, which occur when stars 10 to 20 times larger than our sun collapse in on themselves. Stellar black holes are fairly common and are about 16 kilometers in diameter. And then there's the much larger competition: supermassive black holes. These have a diameter roughly the size of our solar system and a mass greater than 1 million suns combined. One of them, known as Sagittarius A, is right smack dab in the middle of our galaxy. So, how close would a black hole need to be a danger to us? Well, technically, a black hole the size of a 1 millimeter pin could destroy us if it was close enough to Earth, due to its incredibly dense mass and extreme gravitational pull. Our survival all depends on whether we've surpassed the event horizon or not. You can think of this as the black hole's point of no return. Anything beyond this point would have to travel faster than light to escape. Yeah, good luck with that. If Earth got close enough, the side nearest to the black hole would begin stretching toward it. Our atmosphere would start to be vacuumed up, and then huge chunks of the Earth would rip apart and follow suit. If Earth managed to fall into the orbit of the black hole, we'd experience tidal heating. The strong, uneven gravitational pull on Earth would continuously deform the planet. This would generate a tremendous amount of internal friction, heating the Earth's core to disastrous levels. It would likely give rise to earthquakes, volcanoes, and deadly tsunamis. The trifecta of doom. Eventually, Earth would begin to stretch in a process known as spaghettification. And not in the tasty, cheesy, tomatoey way. Let's say you were a superhero and decided to fight the black hole head first. Well, your arms would be closer than your feet, causing your body to stretch out vertically and become more and more compressed. Let's hope your superpower is elasticity. For an average-sized stellar black hole, spaghettification could occur several hundred kilometers away from the event horizon. But for a supermassive black hole, physicists believe that this would happen inside the event horizon due to its size. Eventually, no matter what size it is, anything entering a black hole would be ripped into a string of individual atoms. This would happen to anything that crosses it. People, planets, stars, you name it. Unfortunately, our whole solar system would be doomed. The careful balance of the sun and our many planets would collapse, which could send them crashing into one another. And to add insult to injury, our asteroid belt would get sucked toward us. About 200 of the 552,894 asteroids we know of are more than 100 kilometers across. So, if one hits us, we'd be dead before we would turn into spaghetti. Frankly, I'm not sure which fate would be worse. All of the matter in our solar system would join the accretion disk around the black hole. As matter gets sucked into the black hole, it generates massive amounts of radiation, so even if we somehow survived all the asteroids, we'd likely die from the radiation. Believe it or not, astronomers have discovered rare circumbinary planets that orbit two stars. While this may be a possibility with a black hole and our sun, the extreme tidal forces would likely make our planet uninhabitable. And worse yet, we might get kicked out of orbit or swallowed by the sun or the black hole eventually. Sorry, but there's not an outcome where we win here. But, and this is a big but, maybe we could find a way to protect ourselves in some hyper-reinforced space shuttle. If we somehow made it past the event horizon, we might be in for an even stranger time. Physics as we know it would change. Things like gravity, the speed of light, and even how atoms bind and react may be completely different. The truth is, we don't know what would happen. We can't get any information out of a black hole. Would we get pulled into another dimension? End up in a parallel universe? Or maybe we're already inside a black hole.
So that last video was a good example of how we've upped our production value over the years. We use a lot of fun footage in our videos, movie clips, explosions, and the like, but all those black holes were created by our very own video effects team. That video was made in 2021 during the COVID-19 pandemic, which gave us a lot of time at home to perfect our craft. Working from home during that time made us all very resourceful. I don't know if you could tell, but since I was no longer able to record in my voice booth at the office, I was recording that one in a closet, trying to make it sound not so echoey with a blanket over my head next to an old mattress to absorb some of the sound. Glamorous. Okay, this next one is a blast from the past. My past, actually. It was inspired by all the TV shows I'd seen growing up that were warning me about the dangers of quicksand. People falling in quicksand left and right. What was up with that?
Cut! All right, everyone, that's a wrap.
Movies love quicksand. And why not? It's exotic, it's dramatic, and it's highly exaggerated. Fun fact, it's impossible to become fully submerged in quicksand. But what could happen to you? This is What If, and here's what would happen if you fell into quicksand. The reason why you don't normally sink into the sand when you go to the beach is due to a physics phenomenon known as force chain. Basically, when a bajillion grains of sand are jammed together in one place, their weight gets distributed over a large area, keeping you and your camels safely above ground. But if any water happens to seep up from underground, it will mix with the sand to create a surface that looks solid, but isn't. It's true that real quicksand isn't like what you see at the movies. The reason why you won't sink right through is because quicksand is rarely more than a few feet deep. And even if it was deeper than that, humans are only half as dense as quicksand, so really, you couldn't sink much lower than your waist. That is, unless you struggle. Quicksand is a non-Newtonian fluid, meaning its viscosity changes under stress. In high-stress conditions, like being under the weight of your body, quicksand changes. It becomes liquid, causing you to sink. So if you panic and start frantically trying to get out, the rapid shifting of your weight will only suck you down deeper and faster. On the other hand, quicksand gets thicker over time. So if you just hang around and do nothing, it'll be harder for you to get out. Every minute you're stuck in quicksand increases the risk that you'll suffer from dehydration, starvation, sunstroke, or hypothermia. And if that doesn't give you chills, those hungry-looking eyes might. Depending on where you are, you might even drown. Quicksand is often found near the sea because it's easier for water to rise up through the sand. So, if you're ever caught in the coast, be sure to keep an eye on the time. At best, you'll only have 6 hours before the tide changes. But if not trying to escape and trying too hard are both bad choices, then what are you supposed to do if you get stuck in quicksand? The trick is to stay calm. First, get rid of any heavy items that you're wearing or carrying, as they'll only drag you deeper. Then, try to lean as far back as you can to create more space for yourself. Water will come in and fill the gaps you create, which will make it easier for you to move and pull your body towards the surface. If you can, grab a stick and wedge it underneath your back. This will help to increase your leverage. Hopefully, you'll get help from emergency services, but if not, you can use these tips to get out on your own. It will be a long and exhausting process, since just to free your foot from a puddle of quicksand, moving at a rate of 1 centimeter per second, it would require the same amount of force as it does to lift a small car. And once you're free, you'll probably be in a lot of pain. With all that pressure from the densely packed sand, you might emerge from the quicksand with permanent nerve damage or without a leg. If you do manage to come out in one piece, well, maybe tread a little more carefully in the future. Trees are falling, ecosystems are collapsing, and our infrastructure is crumbling. Crops are failing, and water is scarce. Earth is becoming a dead planet. On the plus side, there's never been a better time to buy property. But who can think about real estate when they can't leave their own home, let alone get out of bed, let alone breathe? This is What If, and here's what would happen if the Earth was as big as the Sun. Everyone knows the Sun is big. I mean, look at it. And that's just how big it looks from about 150 million kilometers away. Just imagine what it would look like if you were standing next to it. Never mind. The Sun accounts for 98% of the mass of our entire solar system. And compared to the densest planet, which is our very own planet Earth, the Sun is more than 1 million times more massive. In fact, it would take roughly 1,300,000 planet Earths to fill the entire Sun. But what if it only took one? Earth would be a very different place if it were the same size as the Sun. Just imagine our whole planet's topography being stretched out. Continents would expand, providing much-needed relief in places where overpopulation inhibits the quality of life, and owning a nice plot of land might actually be more affordable than it is on today's planet Earth. But now we'd also have to consider that every body of water on our planet would have more area to cover. This means that lakes, rivers, and even the oceans would be shallower, making them more susceptible to evaporation and potentially drying out. Marine life would undoubtedly suffer since shallower water would gain more heat from the sun, jeopardizing sea creatures that need colder water to survive. With other smaller water sources beginning to dry up, wildlife on land might have to relocate or travel much farther for fresh water, which would also put them at risk. Us humans would be in an equally precarious position. Not only would we probably start fighting over the limited fresh water that's available, our food crop yields would also start shrinking. Food crops need a certain amount of soil to grow in and to absorb the nutrients they need. If our world was as big as the sun, then, like the water, our soil would have to be spread out to cover a much larger space. Less soil would mean less food, while the demand for food would stay the same. There's also another issue that we haven't considered, which, when we factor it in, makes life on Earth pretty much impossible. Earth being the same size as the Sun is hard enough to imagine, but when you consider a Sun-sized Earth having the same mass as the Sun, it doesn't only jeopardize our survival, it disrupts our entire solar system. Think about it. With the Earth as big as the Sun, you'd pretty much lose the Moon either way. But if a planet has more mass, it will also have a stronger gravitational pull. In this case, gravity on Earth would be 28 times as strong as it is now. We'll get to how this affects you in a moment, but first, let's look at the bigger picture. The reason why our solar system moves the way it does now is because the Sun's mass is so great. Its gravitational pull forces other planets into its orbit. The Sun currently has 98% of the mass in our entire solar system, but now the Sun and the Earth would each have 49% of the mass in our solar system. Would this result in some sort of binary system in which the Sun and the Earth orbited each other? How would this new rivalry affect the orbits of the other planets in our solar system? And would a significantly higher gravitational pull mean that Earth would get hit by a lot more asteroids? Well, there'd be a lot more to worry about than just asteroids. Our satellites would also probably crash down to Earth, while buildings and bridges would crumble and collapse under the increased gravitational pressure. Only thick trees that were low to the ground would remain standing, but it's unlikely that much else could shoulder the added weight. You would be significantly heavier, and you probably wouldn't be able to walk anywhere. Think about it. If you weigh 50 kilograms on Earth right now, it would feel like you weighed 1,400 kilograms on a sun-sized Earth. The cruel twist is that as gravity increases, time would slow down. So you might be able to live longer, but it would probably be a long life spent lying in bed with aches and pains. Luckily, we can wake up from this nightmare because the Earth will never be as big as the Sun. In fact, our planet is actually getting smaller. Our atmosphere leaks, and so we end up losing several hundred tons of mass to space every day. So take a nice deep breath and be glad it's that easy. It's not always a good idea to mess with proportions, and bigger definitely doesn't always mean better. There's something approaching from the distance that you can't stop. It can completely destroy cities and kill tens of thousands of people. It looks like another big wave at first, but as it gets closer, you can see it's not just big, it's huge. It's a tsunami. You should probably run away from it, but instead, we're going to surf it. Seriously? This can't be good. Is surfing a tsunami even possible? And have people done this before? Well, we better get started. The biggest wave that someone has surfed on was 24.4 meters tall. Tsunamis can be around this height, but for our purposes, let's go a little bigger and say ours is 30 meters tall. If you do want to surf on a tsunami, and we don't recommend you do it, you'll most likely have to travel to Japan or the Philippines. This is because they're located in the Ring of Fire, an area in the Pacific Ocean where tsunamis are most likely to occur. But hold up, how do tsunamis occur anyway? Tsunamis are different from the usual waves caused by wind and tides. Tsunamis form due to volcanic activity, but most often after an earthquake occurs in the ocean. If an earthquake happens in the sea that's 6.5 or higher on the Richter scale, you can expect a tsunami to come heading for land. This massive wave will start deep in the ocean and build its way up to the coastline, quickly gaining speed and power. Experts say that a tsunami can move up to 800 kilometers per hour as it reaches the shore. So be prepared, if you can, for a wave as fast as a passenger jet. And although tsunamis start as small bumps deep in the ocean, as they reach shallower water, they become much more massive. So, how would you surf on this thing? Well, let's hope you have a friend that's just as daring as you, because the wave is moving so fast, you'd need your friend to drive up the wave on a jet ski while you hitch a ride on the back. If you manage to get to the top, you'll quickly realize that this wave is completely different from any other wave you've surfed before. That's because tsunami waves don't break, as opposed to regular waves created by wind. A breaking wave curves and cascades onto itself, making it the perfect wall for your surfboard, but generally speaking, a tsunami doesn't have this quality. Apart from the massive size and the incredible speed of the tsunami, surfing on it would be nearly impossible because there wouldn't be much for your board to grip onto. But you're up here now, so what do? Well, your best bet is to really hold on for dear life and hope for the best. Let's be real here, there's no way you're going to be able to surf on this monster. You'll quickly be hurled towards whatever coast the tsunami decides to bring you to. And you probably won't just land on the beach either. You could be several hundred meters or even kilometers inland. It could hurl you against the side of a bus or into a building. And after the tsunami brings you there, that won't be all that happens. After it tosses you inland, the waves will pull you right back out into the ocean. Now, it's not only you in the tsunami, other people, cars, and even entire parts of buildings will all be forced into the ocean, causing even more destruction as they slosh through the tsunami's path. You may think it's over now, but that isn't the case. A tsunami isn't just one massive wave, it's multiple waves. A tsunami can last for up to an hour, with waves up to 30 meters continually hitting the coast while destroying cities and killing people. So once you lose your surfboard, you'd be in the water with everything else being pushed back and forth from the coast and back out to the sea. You'd keep doing this until you eventually drown or die from getting hit by debris. So, although surfing a tsunami would make for a pretty gnarly story, maybe we should just stick to the regular breakers for now. They're not the biggest falls in the world, not by a long shot, but they're certainly among the most famous. Niagara Falls attracts millions of visitors from around the world every year. People come for the history. They come for the romance. They come for the spectacular view. But some people just can't get close enough. This is What If, and here's what would happen if you fell into Niagara Falls. There are 3 different waterfalls that make up Niagara Falls, but the one that gets all the attention is the Canadian Horseshoe Falls. The Canadian Horseshoe Falls is about 57 meters tall and 670 meters wide. Water rushes over its edge at a peak speed of 109 kilometers per hour. dumping about 2.8 million liters of water over its edge every second. Considering its height, its speed, and its raw natural power, it's hard to believe that anyone could survive a trip over the falls. And yet, it's been done several times. Was it skill? Or was it luck? How do you survive a fall into Niagara Falls? The first person to survive a trip over Niagara Falls was Annie Edson Taylor. In 1921, on her 63rd birthday, she crawled into an oak and iron barrel and floated right over the edge of the falls. Taylor performed this stunt for money and fame, but she didn't earn much for her feat. Nonetheless, daredevils seeking to follow in her footsteps were not deterred. In 1928, for example, Jean Lussier went over Niagara Falls in a 182-centimeter rubber and steel ball lined with 32 inner tubes. Lussier survived the fall and spent the rest of his life selling souvenirs to tourists. Not all the daredevils were as lucky as Taylor and Lussier. In fact, of the 16 people who've tried to beat the falls, just a little more than half have lived to tell the tale. To date, only 5 people have survived an unprotected fall down the Canadian Horseshoe Falls. The first and youngest was Roger Woodward in 1960. He was only 7 years old at the time when a boating accident caused him to be swept overboard and over the edge of the falls. Woodward was rescued shortly after and made a full recovery after spending just 3 days in the hospital being treated for a concussion. Today, that event is still referred to as the Miracle at Niagara. Most rescuers and experts at Niagara consider unprotected survival stories to be blind luck. But there are some strategies that might just save your life if, for any reason, you find yourself hurtling 109 kilometers per hour in freezing cold water towards the edge of a 57-meter drop. The first thing you need to remember just before you go over is to take a really deep breath. When you reach the bottom, there will be so much water swirling around you, not to mention the intense pressure of the water falling from above that you could easily suffocate. So, taking a big gulp of air before your fall could buy you some time. You'll also want to take precautions to protect your head. If you can, orient yourself so that you fall feet first. Then, you'll want to wrap your arms around your head with your elbows over your nose and clench your eyes and mouth shut as tightly. Incredibly lucky if you survive the fall, but that doesn't mean your ordeal is over. The water temperature below the falls is around the freezing mark, which gives you about 15 minutes to get out of there before hypothermia kicks in. You'll likely be badly bruised and terribly disoriented, but if you can stay calm and focused, you might just be one of the lucky few to survive a fall into Niagara Falls. Of course, the best way to survive is to pay attention to the warning signs and respect the safety rails. After all, the falls are huge. Do you really need to risk your life to get a closer look?
Now, like I mentioned earlier, we started this show on another social media platform in 2017, the blue one. We were telling interesting stories about human history, science, and culture in short 3-minute segments, and we were doing pretty well, but it wasn't until we launched What If on YouTube on July 18th, 2018, that we found our most dedicated audience. You. Yeah, you've been so instrumental in our growth over the years, growing this channel from 0 to 8.8 million subscribers, 1,500 videos, and over 1.6 billion views on YouTube. Plus, did you know that your support has helped us launch What If in 11 different languages? Yeah, we're in French, Spanish, German, Portuguese, Italian, now Arabic. Plus, we've brought What If to television too. We've started our own channel called Popular Science. Don't worry, we're friends with the people at the website. You can see our 24/7 science programming for free when you stream it on Vizio, Plex, Fubo, Sling, Roku Canada, and more.
Could a monster be lurking in our oceans? And no, we're not talking about the Loch Ness Monster or the Megalodon. We're talking about a creature you've probably never heard of. The Mosasaur. But what's a Mosasaur? Could the Mosasaur have survived the Great Extinction? And if it did, how would it change our oceans? This is What If, and here's what would happen if Mosasaurus were still alive. In 2014, a British tourist spotted a strange creature while on a cruise ship in the Gulf of Mexico. It became known as the Carnival Cruise Monster. And the description sounded a lot like a long extinct apex predator, the Mosasaur. But if the Mosasaur had survived the extinction event which killed off 3/4 of the plant and animal species on Earth, then we'd definitely know about it. It would have completely changed what our oceans look like and how we use them. In fact, if the Mosasaur was still roaming our oceans, the Megalodon might never have existed. But how can one animal have such a huge impact? These nightmarish marine animals were actually giant lizards, kind of like the land-dwelling Komodo dragons, but they evolved for life in the ocean. Their anatomy made them dangerous predators. Imagine a lizard monster with the double-hinged jaw of a snake, massive teeth, and a tail like a shark. Oh, and they could be as large as 18 meters long. That's 4 meters longer than your average yellow school bus. They basically ate anything they wanted. No fish, dolphins, sharks, whales, or even other mosasaurs were safe. Fossils from this species have been found on every continent, including Antarctica. Evidence that these lizard kings dominated the oceans in the Cretaceous period. But they weren't all so ferocious, with some species being as small as 1 meter long. Then, how did they become so terrifying? Their ancestors were more like the marine iguanas living on the Galapagos Islands today. Around 90 million years ago, these lizards would have ventured into the ocean for food. At first, they stayed close to the shoreline, but as they evolved, they started to make the open ocean their home. The evolution of their powerful tail vertebrae made them skilled and speedy swimmers, helping them move further away from the shore. But they also remained close to the surface because, like dolphins and whales, they needed to come up for air. It only took 27 million years for the mosasaur of Jurassic Park to evolve. Of course, the mosasaur in this movie is not very accurate. Even though a real mosasaur was smaller than the one in Jurassic Park, it was still a very dangerous creature. If this species were alive today, it would completely alter our oceans. But why would it change them? And how would it affect the way we use our oceans? Much of the marine life we know today probably wouldn't exist with the mosasaur inhabiting our seas. They just wouldn't have stood a chance against this mighty foe. Instead, the fish and mammals in our oceans would look and act much differently than they do today. They would have adapted special traits and methods to avoid the Mosasaurus. One ecological theory is that predators actually drive evolution because they force prey to adapt, and quickly. In fact, a 2007 study found that the diversity of marine creatures over the past hundreds of millions of years is directly tied to interactions between predator and prey. So, our oceans might actually be even more diverse if the Mosasaurus still existed. But what about us? Well, this giant lizard would make the oceans a much more dangerous place for humans. We would need much larger boats. Small fishing boats and sailboats could be swallowed whole by this creature. Ocean hobbies like sailing and fishing wouldn't be as popular, and swimming and surfing would certainly be life-threatening. And maybe the story of Moby Dick would be about a menacing mosasaur instead of a whale. Thankfully, mosasaurs do not exist today, or our oceans would look completely different, and that's a good thing. If the Mosasaurus were able to survive extinction, what's to say other species couldn't survive too? Just imagine pterodactyls flying overhead. Hang on, because we're about to screech to a halt. That's right, the Earth is going to stop spinning for 5 seconds. How much damage would this sudden stop cause? What would you experience in different parts of the world? And when the Earth starts spinning again, would it still be habitable? This is What If, and here's what would happen if the Earth stopped spinning for 5 seconds. The Earth makes one full rotation on its axis in one day. This gives us day and night. The Earth is spinning because of collisions that happened when the planet was forming 4.6 billion years ago. As a huge disk of gas and dust swirled around the sun, dust and rock grains clumped together, generating forces that kept the planet rotating in one direction. You could imagine it much like a figure skater spinning faster and faster. And with almost no forces in space to slow the planet down, we keep rotating, and will continue to for billions of years. But if the Earth stopped on a dime, would you fly right off the surface? If the planet came to an abrupt halt, the atmosphere would still be in motion. That means, though everything has lurched to a stop, powerful winds would continue to blow. Near the equator, the Earth is rotating the fastest. Here, you'd experience wind speeds of 1,670 kilometers per hour. Those winds would knock you off your feet. But forget about you. These winds would be strong enough to tear up the Earth's crust. So it wouldn't matter if you were out in an open field or inside a steel-reinforced building. These winds would obliterate you. And these storms can move houses off their foundations, send cars flying, and even tear apart concrete structures. The winds from the Earth's emergency brake would be 3 times stronger than that. So if the crust under your feet didn't crumble, you and a lot of other stuff would likely go flying a great distance. But not off the face of the Earth. The escape velocity, or the speed you need to escape the Earth's gravitational forces and enter space, is about 40,000 kilometers per hour. In other parts of the world, like New Zealand or France, you'd experience slightly weaker winds, but at 1,180 kilometers per hour, these would still be much stronger than any storm ever. These winds would pretty much destroy everything, but they wouldn't be the only hazard you'd need to keep an eye out for in these short 5 seconds. Our planet is not a perfect sphere. It bulges near the equator due to the centrifugal forces generated by the planet's rotation. If the rotation stopped, the Earth would transform quickly into a perfect sphere. All the water gathering near the equator would flow away toward the poles, generating a massive tsunami. 5 seconds later, when the planet returned to its full-speed rotation, that water would backtrack. A wall of water would slam into everything and everyone, twice. That's one heck of a storm. Maybe the only place you'd be safe in this scenario is near the North or South Poles. Here, the wind would be the mildest. Now, you must be relieved to hear that the Earth has returned to its normal rotation after all this, but like I said, there would be nothing left on it. Every building, all farmland and all technology would be demolished beyond recognition. Billions of people, if not every single person on Earth, would die from the brute force of being slammed by the massive gusts of wind. So, if you're looking to survive this apocalyptic scenario, you'd better start building an underground bunker. Luckily, it's expected the Earth won't come to a halt anytime in the next few billion years.
In the past few billion years, Earth has been pummeled by asteroids, crashed into other planets, and frozen over several times. Not to mention being ruled by all kinds of crazy life forms. Sometimes it's a wonder that our blue homeworld has survived it all. But if we want to take a whirlwind tour of our planet's history, we'll have to start way back at the very beginning. Some 4.5 billion years ago, our solar system began to emerge out of a dense cloud of interstellar gas and dust. This cloud collapsed into a swirling disk of matter that got hotter and hotter and hotter until hydrogen fused into helium. And just like that, our sun was born. And baby Earth was on its way too. After the birth of our star, all the matter on the farthest ends of the spinning disk began to clump together. These clumps would be the seedlings for the planets and moons in our solar system. As they accumulated more matter, they grew bigger and more spherical. The clumps in the cooler regions of the solar system were mostly made of ice, liquids, and gases. Closer to the sun, all the rocky material formed the inner planets like Mars and Earth. This young Earth was incredibly active, volcanically speaking. It spewed out gases like hydrogen sulfide, methane, and carbon dioxide. These gases made up the very first atmosphere on our planet. Early Earth was constantly bombarded by large asteroids and comets, and soon Earth experienced an even more violent collision. Theia, a planet the size of Mars, slammed right into our young world. This epic collision threw chunks of matter all around Earth's orbit, and then gravity bound them together into what we know now as the Moon. On this hot, early Earth, there were no oceans. All water existed as gas. But 3.8 billion years ago, our planet cooled enough for water to condensate and become liquid. The very first primitive ocean covered this young Earth and turned it into a water world. H2O is an essential ingredient for creating living things, so with all that water, life appeared on Earth about 3.7 billion years ago. These earliest forms of life were microscopic organisms, but it was nearly a billion years after that that some of these organisms changed the course of the world. Earth didn't stay as a water world very long. Soon, the very first continents emerged from the ancient ocean. Scientists call them cratons. As more and more land rose from the ocean, the very first supercontinent appeared on the planet. Valbara wasn't exactly a supercontinent. It was pretty small. Scientists think it was smaller than the continent of Australia. Around 2.4 billion years ago, cyanobacteria evolved to become our planet's first photosynthesizers. Finally, we had some oxygen producers to make Earth's atmosphere much more hospitable. And the rest is history, folks. Just kidding, we've still got a long way to go. With all this new oxygen, Earth's atmosphere had much lower levels of carbon dioxide.
And that made the planet icy cold. Much of our young world froze over as Earth saw its first ice age. Now, as Earth's atmosphere was changing, the continents were moving too. They broke up and reassembled into the next supercontinent, Rodinia. Rodinia was a real supercontinent. It may have been the largest supercontinent to ever cover the planet. And life? Well, life finally became more complex. But then something happened. Rodinia broke apart and a new supercontinent assembled. This one was called Pannotia. Then, between about 540 and 485 million years ago, there was an explosion of new life. This time was called the Cambrian explosion, and the animals that evolved during this period had hard body parts, like shells or spines. The most famous of all were the alien-looking trilobites. Around 440 million years ago, the climate suddenly shifted and the temperature of the ocean changed dramatically. Earth saw its first mass extinction event. This was the Ordovician Silurian extinction, and a majority of the life that had been spreading around the planet vanished. Many of these life forms laid the foundation for the ecosystems that we have on Earth today. Somewhere between 420 to 350 million years ago, the first trees arose from Earth's soil. And the first animals made their way to land, too. 250 million years ago, the planet was covered by our last vast supercontinent, Pangaea. Sadly, it was also during this period that Earth witnessed the greatest mass extinction event in our history, the Great Dying. Huge amounts of greenhouse gases and accelerated global warming wiped out about 90% of all species on Earth. But this mass extinction helped pave the way for the next wave of animals to evolve. 240 to 230 million years ago, the first dinosaurs appeared. For the next 150 million years, they'd rule the land. If you were there, you'd have witnessed the gigantic sauropod Argentinosaurus, the largest land animal ever. Or you might have been chased by one of the Earth's greatest apex predators, the T-Rex. And you'd also witnessed Pangaea breaking up and forming the continents we know today. Okay, you may already know where this is headed. 66 million years ago, an asteroid slammed into our planet, right where Mexico sits now. And it coughed up so much debris into the atmosphere that it blocked out the sun. This led to devastating climate changes that caused the dinosaurs to die out. In the next wave of emerging animals, mammals became more common. Around 6 million years ago, the earliest known humans started walking this world. This species was called Sahelanthropus, though they still likely walked on all fours. 4 million years ago, early humans began to walk upright, and about 1 million years later, they developed the first known tools, which they used to break things. Some 800,000 years ago, things sparked. These early humans discovered how to control fire and could now cook food and provide themselves with heat. Their brains continued to evolve, now more rapidly than ever. These humans learned to interact with each other and the surrounding world in whole new ways. Then, between 40,000 to 15,000 years ago, all other human species besides Homo sapiens went extinct. 10,000 years ago, Earth saw its earliest farmers. These previously nomadic humans stopped wandering the planet and finally put down their roots. Jumping way forward to about 250 years ago, the Industrial Revolution took place. We went through major technological, socioeconomic, and cultural transformations. Rural-based farm societies became more industrialized urban ones. Our human population continued to grow. By 1804, we reached 1 billion. By 1927, we'd hit 2 billion. And since the 1960s, the global population has risen faster and faster to where it is now, at over 8 billion people. And now there's a new threat to human existence and many other forms of life here on Earth: climate change. Temperatures and sea levels are rising worldwide, and biodiversity is declining. We could be on the verge of another mass extinction event if things don't change.
Now that was a good video. I like that one. That was just 2 years ago, so we'd really come into our own. Now that one has nearly 7 million views in 2 years, which is a pretty big accomplishment for us. Thanks to our writer Trevor Silverstein and editor Amanda Zola for that. Now, you don't see me in the videos yet. That would start a few months after that last episode. But these episodes definitely feel more comfortable than our early 2018 offerings. Hey, you know what else is comfortable? Well, these What If shirts, made of 100% comfortable fabric. I'm comfortable in one right now. This is the point in the show, obviously, where I tell you about our merch store. Yeah, we sell these shirts to viewers like you, so you can look cool and knowledgeable, and so you can get approached by friends and neighbors who say, "What if? I love that channel." 6-7. Anyway, no pressure, but if you want to be cool, shop.underknown.com is a place to get them. And you should get them now, because they're moving at the speed of light. Well, not really. The shipping is a few days at the very least. But lots more stuff in the shop too. Hoodies, stickers, mugs, books, posters. Check it out after the show.
They're the deadliest thing on Earth. They suck your blood and spread disease, killing nearly 1 million people each year. Are we talking about vampires? Lions? Gorillas? Actually, none of these things. We're talking about mosquitoes. Are mosquitoes really this deadly? What would happen if they all disappeared? Would humanity be better off? This is What If, and here's what would happen if we killed all mosquitoes. It may sound unusual that a little bug could be this deadly, but it's true. Mosquitoes spread diseases like malaria, yellow fever, and the dengue virus. They do it by biting someone who has a particular disease, and then biting you and injecting their saliva into your body. The saliva then enters your bloodstream, causing you to contract whatever virus or bacteria that the mosquito picked up. And it's not just humans they affect either. Animals and farm livestock all around the world suffer greatly from mosquitoes. Just a single bite can be fatal. So, how do we get rid of these bugs? Well, first, we have to figure out exactly how many mosquitoes there are in the world. That's incredibly difficult to find out. It's estimated that there's 7 trillion of them in Alaska alone. Yeah, that's right, Alaska. Due to global warming and ocean temperatures rising, mosquitoes can live in places like this. And around the world, there are trillions of other mosquitoes. There's a number of ways we could get rid of them. Bats eat mosquitoes without any risks. They can eat 600 mosquitoes in an hour, so if we had enough bats, in theory, they could effectively wipe out mosquitoes all around the world. But then how would we get rid of the billions of bats in the sky? Okay, maybe that's not the best idea. Another thing we need to understand is how mosquitoes reproduce. You may think they're sucking our blood because we taste good and they're hungry. But instead of feeding themselves, they're actually doing it for their larvae. So, if we somehow got rid of all our blood and... Wait, I know where this is going. Yeah, that's not going to work either. Instead of these options, we may need to release genetically modified male mosquitoes. Ones that don't bite and can only produce sterile offspring. It could take several decades, but with enough of our genetically modified mosquitoes producing sterile offspring, mosquitoes would eventually be eradicated. So, now that they're gone, what would happen next? Well, millions of people wouldn't be getting sick and dying each year. You could enjoy being outside in the summer without any fear of being bitten, and animals would be much safer as well. That's right, not many bad things would happen if we got rid of all the mosquitoes. But what about the circle of life and all that? Don't mosquitoes contribute to the food chain? Sure, some birds, bats, and frogs eat quite a lot of mosquitoes. But they're still not a hugely significant part of other creatures' diets. And these animals will survive without mosquitoes. And although mosquitoes do pollinate plants, it's not significant enough to justify keeping the species alive. But still, is getting rid of mosquitoes the right thing to do? After all, we would be getting rid of an entire species. We should keep in mind that there are thousands of different species of mosquitoes, but only 6 of them bite us and spread disease. Not only that, but there are some theories that mosquitoes may help to protect the Amazon rainforest. That's because they're so deadly and annoying to the people trying to cut down the rainforest that at times the bugs actually prevent them from doing so. And let's be real for a second. The human population is growing incredibly fast. Maybe mosquitoes are helping us to keep our population in check. Wait, what am I saying? This would most definitely be a good thing. There would be less disease, fewer people dying, and very few negative consequences.
Where did everybody go? Zombies? Rapture? One big surprise party? Off the planet? For whatever reason, you are the last human on Earth. So what do? Eat like a king? Move into Buckingham Palace? Drive fast, blow things up, be naked all the time? Or would you pretend you weren't alone? How long would you last? This is What If, and here's how you can survive as the last person on Earth. So, you wake up one day and find you're the only person left in the world. Kinda cool, right? No obligations, no rules, no limits. Go nuts! Step 1. Enjoy the good things while you can. Go for the exotic fruits first. If your mangoes and bananas are imported from overseas, chances are they'll be hard to come by. So eat them while you can and enjoy every last bite. Step 2. Find a secure source of fuel. You might think that with no one stopping you, you could go anywhere. But not so fast. All those abandoned cars, boats, and planes you see lying around will be useless in about 2 years when their fuel goes stale. Guess you'll be sticking around, but for how long? Step 3. Find a place to live. If water, food, and shelter are your basic needs, shelter would be the easiest to come by. You'd literally have a world of homes to choose from. But be careful where you settle down. Cities would become dangerous, since without proper maintenance, they'd start to fall apart pretty quickly. Nature's elements, rain, frost, and heat, would take their toll. Rot and mold would become widespread, and vegetation would crack through concrete and break through glass. But even if you were able to fight back against nature's reclamation of the land, all it takes is one bolt of lightning to start a citywide fire, and you can't call the fire department, so run for the hills. Step 4. Get yourself some protection. But even the country isn't all that safe. First of all, there are predators you'd need to defend against. Wild dogs, feral cats, bears. But you'd only have to worry about them as long as you could still breathe. There are more than 400 nuclear power plants in the world. And once their automated safety systems began to fail without human supervision, there would be meltdowns across the planet, rendering many regions simply uninhabitable. Step 5. Find some food. In terms of food, the city would be your best bet. Supermarkets have enough canned and frozen food to last you for decades. Whereas in the country, crops and livestock would start to dwindle without proper care or protection from predators. But if natural is more your style, you'd have to go back to the old ways of hunting with a spear or bow, since ammunition would be limited and harder to come by. Maybe you could grow your own little vegetable garden, but that would cut into your water resources. Step 6. It's all about the water. Without other humans, you'd be without electricity. Water pumping stations and treatment works would shut down, and the fresh water kept in reservoirs would go stale quite quickly. You could rely on bottled water, and you'd probably have thousands of liters to go through, but eventually you'd have to learn how to purify your own. Step 7. Start learning. You'd have to teach yourself a lot of things, but lucky for you, you've got a lot of time on your hands, and millions of books out there with all the information you'd need to survive effectively on your own. So while it might be hard at first, you could technically survive as the last human on Earth. But would you really want to? Humans evolved together as social creatures in order to survive. We joined forces against hunger and harsh weather and built families and communities to share stories, empathize, and keep each other happy and healthy. Human contact has been scientifically proven to build trust and reduce stress. So while it's apt to cramp your style, be glad it's a small world. We need each other more than you think.
No, this is not a video about the fictional 70s blockbuster Jaws. We're talking about a fish that's much, much smaller than a great white shark, but that's got a bite about 2 times greater. Supposedly, its teeth are so sharp that if it were to bite you, you would only realize it after you saw blood. But what if you were attacked by a school of these colorful, fast-moving carnivores? How much would you feel? And how long would you last? This is What If, and here's what would happen if you fell into a pool full of piranhas. Piranhas have been around for a really long time. Fossil evidence puts the piranha's ancestors in South America as far back as 25 million years ago. And the modern piranhas we know and love today have been here for 1.8 million years. So we've had some time to learn about these fearsome little river dwellers. But how much of it is true? Pay attention. What you're about to see might just save your life. That piranhas are vicious, bloodthirsty creatures that will tear you apart in minutes is largely a myth. In 1914, former US President Theodore Roosevelt was on a survey expedition in Brazil, where he witnessed a group of locals tossing a dead cow into a river that they had stocked with starving piranhas. The feeding frenzy that followed led Roosevelt to see piranhas as the embodiment of evil ferocity. He compared their teeth and their jaws to those of sharks and claimed that their preferred prey is usually much larger than themselves. Well, the story stuck, and naturally, like Jaws before it, Piranha became a 1978 cult classic, spreading several myths about the fish that a lot of people still believe. The real truth is that piranhas are relatively calm fish, and most of them are scavengers that feed on insects, worms, and plant material in the rivers where they live. Of the few species of piranha that are attracted to the smell of blood, well, they tend to go for prey that's roughly the same size as them. In fact, if you fell into a pool of piranhas, chances are they'd actually be scared of you. Piranhas aren't really interested in humans, unless they are extremely hungry and the human is already dead. But it's not like someone would starve a pack of piranhas and put them in a pool just to watch them eat something. At worst, you might get nipped and gnawed on a little, which is scary enough, but you can rest assured that there has never been a scientifically proven case of a human being killed by a piranha. Sorry, gory B-movie lovers. But don't let me spoil all the fun. Even though you know the truth now, the idea of what piranhas can do is still terrifying. These fish typically grow up to 50 centimeters long. They hunt in packs and have a bite force that's 3 times their body weight. This means that, relative to its size, a piranha bites harder than a great white shark, harder than an American alligator, harder than a T-Rex, and even harder than a Megalodon. And while it's highly unlikely to happen, if for some reason you were attacked by a school of piranhas, roughly 400 of them could turn you into a skeleton in about 5 minutes. But of course, there's always a bigger fish. So Even if piranhas aren't something you have to worry about, there's still a lot of underwater that you'll want to avoid. Can you imagine being swallowed whole by a whale?
Wake up! Are you late again? Sometimes we wish we never had to deal with this morning struggle. But what if you just never went to bed? What if you figured out how to keep yourself awake forever? How long could this sleepless forever last? Could you even be productive without recharging every night? When would your friends start telling you to get some rest? And what exactly would happen to your body? This is What If, and here's what would happen if you stopped sleeping. How often have you needed just a few more hours to finish off a project, get ready for a date, or enjoy your day off? If you took sleep out of your daily routine, you'd have all 24 hours of the day to do everything you never had time for. What's a few yawns and some minor tiredness if it meant you never had to waste any more time lying in bed for no good reason? Turns out there are plenty of good reasons to sleep. The average person spends 1/3 of their life lying in bed, eyes shut, snoring away. Sounds like a waste of valuable time, but not for your body. While you sleep, your body releases hormones and repairs tissues, replacing your old cells with new ones. If you worked out that day, you need a good sleep to let your muscles grow and your fat burn. So what happens if you don't sleep? Not much at first. After just 24 hours, you'd feel completely fine. In fact, you'd feel better than fine. That's because sleeplessness stimulates the mesolimbic pathway in your brain. This pathway would release dopamine, and you'd feel happy and full of energy. But don't be fooled by all that happiness. It's not going to last long. Soon after reaching the 24-hour mark, all your reactions would slow down. Your brain would start to forget what you were doing. Outwardly, you'd appear to be drunk. Wait, where were we? Right. Now what about 2 days without sleep? At that point, your body would start shutting down. It would stop metabolizing glucose properly, leaving you with no energy supply. You'd start looking very pale. Your eyes would turn red, and then more bad news, your wrinkles would become more visible. On day 3, that's when the real fun begins. Hallucinations. Starved of REM sleep, your brain would bring all your dreams and nightmares to life. At around the 72-hour mark, you'd start breaking down your own protein, your muscles. So say goodbye to all that muscle mass you worked so hard to build up. Your body would keep using up all the energy sources it could find. Glucose leftovers, your muscles, fat, tissue. After about 2 weeks, your immune system would be so weak you could die from the common flu. Eventually, 3 weeks after your last sleep, you'd probably die of a heart attack. If you've got a little extra muscle or fat on your body, you could stay alive just a bit longer. But we don't recommend anyone try this at home anyway. So grab yourself a pillow and take a siesta. If it seems like you're always tired, make sure you're getting the prescribed 6 to 8 hours of sleep per night.
Ooh, that was another one of our early videos. We published that one back in October of 2018, over 7 years ago. And I have to assume it's got 6.1 million views because people are curious about the subject and not because they like listening to cringe voiceovers. Again, I'm allowed to make fun of the voiceover guy. That was me as a young, aspiring voiceover artist, head in the clouds, thinking I'd be the next David Attenborough or Morgan Freeman of voice work. No. Because that was so long ago, it's 100% true that the only way to go was up. So let's travel ahead in time to see how much better. Exactly 1 year later, we'd grown a bit bigger as a group by then and had moved into our very first office. You'll get a glimpse of the alley behind it here in the first 10 seconds of the video when our editor Marina used her video effects skills and made our other editor, Taylor, appear out of nowhere and blew our young What If minds.
If time travel is possible, why haven't we met a single time traveler yet? And if we did meet one, how would we know they weren't faking it? What would their time machine look like? And how would it operate? Would there be a set of rules for time travelers to follow? And what would happen if they decided to break them? This is What If, and here's what would happen if you met a time traveler. In 1998, a gentleman by the name of John Titor arrived from the future, or so he said. In his timeline, as he claimed, General Electric had managed to invent time travel in the year 2034. He even showed and described his time-traveling device in great detail. And then, Titor vanished, as abruptly as he appeared. Did he finish his mission? Or was he real at all? How could we know? If we were able to prove that someone has traveled from a different time, it would be very cool for science. Although it might overwrite Albert Einstein's theory of relativity. Einstein approached time as a fourth dimension. Space is a three-dimensional spectrum that provides us with length, width, and height. Time offers direction. Together, they form a space-time continuum, and it can be affected by gravity. According to Einstein's theory of relativity, gravity is a curve in space-time. And technically, because space and time are one, gravity could bend time as well as space. But you'd need something really, really big to notice any changes in the movement of time. If you somehow managed to get yourself close to a black hole like Sagittarius A, you'd be experiencing time at half speed compared to people on Earth. This is because Sagittarius A packs a mass of 4 million suns into an indefinitely dense point, creating a very strong gravitational field around it. Another way to travel in time is to move really fast. The closer you get to the speed of light, the slower time passes for you. If you were a passenger on a train that somehow could travel at 99% of the speed of light, for every year you spent on the train, 223 years would have passed back at the station. That would make you a time traveler into the future. But what about traveling back in time, just like John Titor said he did? Titor claimed that this little machine is what made time travel possible in any direction. The C-204, as he called it, allowed him to manipulate gravity with the help of 2 microsingularities that were packed inside. It also had gravity sensors to lock the machine and time traveler in a fixed place in space. Titor had this machine installed in a car, pretty much like the good old time-traveling DeLorean did. But it would only take him as far as 60 years from his time. How would you know that Titor was actually traveling in time and not just making it up? Proving that someone really is a time traveler might be even harder than time travel itself. Time travelers could make predictions about the future, show their futuristic technology, or even undergo some genetic testing to support their story. Maybe the best way to prove time travel is real would be to take you with them on their next adventure. Of course, there are easier ways to prove the possibility of time travel. In 2009, the world-famous theoretical physicist Stephen Hawking threw a party. Not just any party, but one to which only future time travelers were invited. Hawking didn't send off invitations until after the party. He believed that if travelers from the future arrived before the invitation was released, that would prove that time travel will become possible one day. He sat there, waiting for hours, but nobody showed up. That doesn't mean time travel is impossible. There is a chance that time travelers from the future will learn to use wormholes or bridges in space-time. We haven't seen one of those yet, but the theory of general relativity predicts that they exist. The biggest problem with wormholes is that they're microscopic and collapse too quickly for a human traveler to go through. But maybe the reason nobody attended Hawking's party is that time traveling might not be that precise. maybe the guests from the future did arrive, but they were too late for the party. Or maybe going back in time is strictly prohibited for time travelers, because if they do, they might change their timeline completely. Perhaps they're just trying to avoid the risk of spreading any diseases from the far future onto us. Or maybe the information about time traveling is so highly classified that only a few people would be trusted with it. Maybe traveling back into time isn't possible after all. Maybe time can only move forward and never backwards. Maybe John Titor was one big lie. We have a few more years until 2034 to find out. In a way, we already have time travelers in our lifetime. Astronauts on the International Space Station are moving at 8 kilometers per second. This makes them age slower, although the difference is measured in hundredths of a second. But if you're listening, you're invited to a reception for time travelers, hosted by Stephen Hawking. The party will take place at the University of Cambridge, United Kingdom, on June 28, 2009. No RSVP required. And hey, if you have a chance to jump in a spaceship and enjoy the time-traveling effects of a black hole, do it. Just make sure not to fall into that gravitational monster.
The Earth has been hurtling towards Jupiter for the past 242 days. And now, it's about to make impact. Now, we're so close to the giant planet that it's the only thing that fills our sky. Ground temperatures on Earth are rising uncontrollably. Our atmosphere is igniting into flames, and the scientific community is scrambling to provide answers. What will happen when the two planets collide? Is there any chance that we could pass right through the gas planet? And how would this collision transform Jupiter forever? This is What If? And here's what would happen if Jupiter swallowed Earth. One way that scientists could find answers would be by looking into the past, because this wouldn't be the first time that Jupiter has collided with another planet. Nearly 4.5 billion years ago, Jupiter was involved in a violent collision with a planet 10 times the mass of the Earth. In that case, the collision completely transformed Jupiter's core, but what happened to the other planet? And what can that tell us about our own planet's chances of surviving a crash into the gas giant? To get some answers, let's travel back to 4.5 billion years ago, when Jupiter was just a young planet trying to find its place in the universe. Back then, Jupiter's gravitational pull became 30 times more powerful in just a fraction of a million years. This destabilized the orbits of nearby infant planets and caused some of them to crash into Jupiter. It's believed that one such planet was 10 times the mass of Earth, and it was mainly a silicate ice core. The planet hit Jupiter with an impact speed of 46 kilometers per second. Jupiter only lost a small amount of mass from the collision, but its original core was completely changed. Before the impact, Jupiter had a dense central core of heavy elements, and the rest of the planet was made up of hydrogen and helium. After the impact, the infant planet's silicate ice core merged with Jupiter's, causing Jupiter's core to become diluted. The heavy elements spread out and mixed with the outer layers of Jupiter. While this collision was a defining moment for Jupiter, it meant the end of the road for the other planet. So, what are the odds that the Earth's fate would be any different? Well, let's find out.
The Earth orbits around the Sun at an average velocity of 29.78 kilometers per second. At this speed, if the Earth were to just leave its orbit around the Sun and head straight for Jupiter, it would take about 242 days to get there. Throughout our journey, Jupiter would shine like a bright star, growing bigger day by day, hour by hour. By day 6, Jupiter would appear as bright as our moon. Soon, we would start to notice our daylight becoming dimmer. We'll only get about 50% of our normal sunlight when we reach Mars's orbit. Luckily for us, the Earth's atmosphere would act as a buffer, so we wouldn't experience the cold right away, but that will only last a while, so you'll need to invest in some heavy-duty winter gear. To put it in perspective, Mars has a surface temperature of minus 63 degrees. So that's basically what we'd have to look forward to. Once we speed through Mars's orbit, we'll pass through the asteroid belt. We'll get to see beautiful meteor showers lighting up the sky, but we'll also be at risk with colliding with some of those meteors, so let's keep moving. After 242 days of traveling through our solar system, we would finally reach our destination, Jupiter. As the Earth is pulled into Jupiter, our planet's velocity could increase until it reaches 60 kilometers per second. That's 250 times faster than an airplane flies, so you'll want to hold on tight. Oh, and did we mention that Jupiter has 79 confirmed moons orbiting it at all times? So there's a serious risk that we could collide with any of them as the Earth is pulled in closer. And if we do happen to avoid all those moons, things would only get worse. As we crash into Jupiter, both planets' atmospheres will be compressed, rapidly increasing the temperature and essentially setting the air on fire. But at least we won't have to worry about colliding with Jupiter's core, because we'll never make it there. Our planet is too small and would burn up in the atmosphere before that ever happens. But this would have a huge impact on Jupiter, as the Earth's remains would completely mix into its atmosphere. So if you ever notice our planet going off course and heading towards Jupiter, you might want to jump off along the way. Maybe right as we pass over Mars. When your stomach is working normally, you probably don't think about it at all. But when it starts acting up, you can't ignore it. And right now, it's definitely speaking to you. Because all of a sudden, you have no stomach acid. Why could it lead to infection? How powerful is stomach acid? And would you excrete food whole? This is What If, and here's what would happen if your stomach acid disappeared. Your stomach is powerful, and of all the digestive juices it produces, hydrochloric acid is the most extreme. This liquid form of hydrogen chloride is also used in fertilizers, fireworks, rubber, and steel. If you inhale it, you could suffer from nose and breathing issues. But this dangerous acid is essential for your well-being, and without it, you'd be in big trouble. So, we're going to follow a piece of food as it travels through your digestive system and into your acidless stomach. But first, let's see what normally happens when you eat. You bite into a delicious bagel. Immediately, your stomach begins to release gastric juices. It uses 3 glands in your stomach's lining to create this acidic concoction. As you chew and swallow your food, it becomes what's called a bolus. This travels down your esophagus and into your stomach, where it gets mixed with the gastric juices. As I mentioned before, this mixture is potent, but luckily, you have a protective shield made of epithelial cells in the lining of your stomach. Without epithelial cells, the gastric acid would eat away at your stomach lining. As extreme as stomach acid is, it does 4 important things for your body. After the food moves through your small intestine, it goes into your large intestine. And then, well, you know what happens next. Your whole digestive tract, from your mouth to your anus, is vital for breaking down food, but your stomach is the star of your digestive system. So, how would things change if you lacked stomach acid? Well, you'd take a bite of that delicious bagel. Stomach acid doesn't just disappear. But not having enough stomach acid, or hyperchlorhydria, is a common health issue. In the United States, 22% of the population suffers from it. Age, stress, processed foods, and overusing antacid can all cause problems for your stomach. The good thing is that you can always eat some ginger, fermented vegetables, or drink some apple cider vinegar. They can reduce inflammation, break down food, and increase stomach acid, giving you a happier digestive system. It's easy to take your body for granted, but it works hard, and we should all treat it like the beautifully complex instrument it is. Taking care of your body could be as simple as going to the bathroom as soon as you feel the urge, even if you're on a long road trip.
Human beings have existed for 300,000 years and have managed to live in many unstable environments. We've survived ice ages, devastating pandemics, and world wars. But how would we fare even further back in time? What about 400 million years ago, when deadly marine life dominated our oceans and creatures on land were practically non-existent? Let's imagine your what-if time machine happened to break down right at this moment, trapping you in the Devonian period. What would life be like? Where would you live? And how long could you last? This is What If, and here's what would happen if you lived in the Devonian period. Stroke of luck, our time machine stops you on land. At this point in time, 85% of the Earth was comprised of ocean. Only 2 supercontinents existed 600 million years ago, Gondwana and Laurussia. Gondwana had a massive mountain range, similar to the Himalayas, which slowly eroded, washing sediments into the ocean. These sediments provided nutrients that allowed marine life to flourish, giving rise to the Devonian period. Okay, enough background. Our first step for survival is to seek shelter. In the early Devonian period, trees and plants had not yet evolved. But there's lots of moss. The land was barren, Mars-like, and surrounded by water. You might need to get a little creative to build shelter. If humans actually evolved in this period, they would likely be naked with little material to make clothes. Or maybe we would develop a new fashion line, made of moss, seashells, and fish bones. Ooh la la, how Devonian chic. Speaking of fish bones, you'd want to be very careful about fishing. Many scary sea creatures would be happy to eat you. Like placoderms, a species of armored fish with huge, sharp jaws that could easily make you bite-sized. In the early Devonian period, placoderms were the apex predator and would grow up to 10 meters. Let's say you got lucky and actually caught a fish without being eaten yourself in the process. How would you cook it? With no trees for fuel, you'd have to find some very dry moss and start rubbing some rocks together. Luckily, the climate was pretty warm, meaning you wouldn't freeze at night. But with very little kindling available, you might be better off sticking to a raw diet of mollusks and other early arthropods. You'd also have to move around a lot to keep finding these critters, so be prepared to do a lot of walking. I can see you're getting a little tired and bored of existing out there. Let's fast forward another 40 million years toward the late Devonian period. This period is also known as the Devonian extinction. But don't worry, it could actually be a really good time for you, fearless traveler. Since by this point, almost 79 to 87% of all existing species were wiped out. But what could cause such a catastrophe? Scientists believe it was the evolution of plants. Vascular plants began dominating the environment, including trees, ferns, and flowering plants. Their roots broke up the rocky ground and released nutrients and minerals in the water. These nutrients fed algae, which multiplied rapidly and produced greedy bacteria that fed on oxygen. Many regions of the ocean became anoxic zones, and much of the marine life died off due to the lack of oxygen. And with more air in the atmosphere, some sea creatures slowly adapted and made their way to shore. So you can breathe easier knowing there are less predators in the water, but look out for your new neighbors on land. These land dwellers, known as lobophinns, were the early ancestors of amphibians and all four-legged vertebrates. In fact, the Devonian period got its name from the fossils of lobophinns found in Devon, England. In 2004, a lobophin fossil was found in the Canadian Arctic, known as the Tiktaalik, which is considered to be the species between fish and land-dwelling tetrapod. It had a crocodile-like head, bony fins, sharp teeth, and a flat body almost 3 meters long. Its fins had partial wrists, allowing it to crawl on land. So if I were you, I would quickly hide if I saw a Tiktaalik coming my way. The other dominant species were cartilaginous fish, with skeletons covered in, you guessed it, cartilage. These are the ancestors of sharks and rays. But you don't have to worry about sharks. Oh no, there's something far bigger and scarier. I'd keep my distance if you happen to see a Dunkleosteus swimming around. These were the deadliest predators of the Devonian age, with thick bony plates covering their skulls and razor-sharp jaws. Some would grow up to 10 meters in length. Their jaws were strong enough to chomp right through another Dunkleosteus. With few fish left because of plants hogging the oxygen, these placoderms were starving and desperate enough to eat each other, so be very careful where you bathe. With more trees and plants emerging in your environment, you could finally create some helpful tools like spears, fishing hooks, and rope. You could improve your diet and maybe become a vegetarian. And you could fashion some new clothes that aren't so irritatingly itchy. By the late Devonian period, you might even be able to build yourself a treehouse in the Archaeopteryx, the first tree on Earth which grew up to 30 meters tall, with a trunk 3 meters wide. This may be nice for a while, but if you think the Devonian period is easy, you might want to plan a hasty exit before the Cretaceous period rolls around. Who knows? Maybe ancient life actually found a way to escape our planet.
Now, that was an interesting one. That video was produced in 2020, just before the pandemic hit. At that point, we were hoping to expand the What If universe and bring in a female narrator. That was Kula. I thought she was great, and she added a lot of depth to the roster. But I think what happened was that we botched the rollout of the second host, and our fans were just confused. By that point in our history, the fans were accustomed to hearing my voice, and anything deviating from that just wasn't what they were looking for. But who knows? Maybe we'll try it again someday. Okay, this next one is exciting. It's from July of 2023 and has 6 million views. It marks a bit of a turning point for us here. We'd been toying with the idea of adding a character who could do things that I couldn't, like travel through space and physically demonstrate getting destroyed by all the dangers of outer space. And this next video was really a prototype for our show Chase Dies in Space.
Welcome to hell! Sorry, I meant Venus. Welcome to Venus. Some say it's Earth's twin, but this world is nothing like home. And you're about to experience this scorching hot landscape firsthand. Your mission is to spend 5 seconds on this hellish planet. And trust me, these are going to be a very long 5 seconds. Venus is the second planet from the Sun and our nearest neighbor. At its closest approach, Venus is a mere 40 million kilometers away from us. After just 4 months in space, you'd finally be able to witness this beautiful but deadly planet up close. 4.5 billion years ago, Venus and Earth formed in the same corner of our solar system. This space rock is about the same size as Earth, and its gravity is similar too, but unlike our home, the surface situation on Venus is extreme. We know this because we've sent probes to this scorching world. Some probes orbited it, some made a flyby, and some even landed on the surface of Venus, but those didn't last very long. What happened to them? Well, that's what you're about to find out. Time to make your way down to the surface. Don't these clouds look beautiful? Well, don't inhale them. These yellowish bands streaking across the sky are clouds of sulfuric acid. If you could only get a whiff of them, you'd smell the reek of rotten eggs. But to do that, you'd need to remove your helmet, and I definitely do not recommend that. At a height of 50 kilometers above the surface, visibility is poor. You'd hardly be able to see anything. The incredibly thick atmosphere would block views of this planet and its tens of thousands of volcanoes. The atmosphere is mostly made up of carbon dioxide, and because it's so thick, it traps heat on the planet's surface, keeping it nice and toasty. Just how toasty are we talking? You're gonna find out the hard way. As you descend another 15 kilometers, the haze would begin to clear. The world below would finally reveal itself. A rust-colored surface covered in mountains and volcanoes. Looks like this volcano is still active.
You'd fly around a little to collect some samples and take in the view. Yep, the atmosphere is mostly carbon dioxide with traces of nitrogen. That checks out. Okay, well, let's see if you can land here. This looks like the spot.
Mission Control, am I clear for landing? Mission Control? Looks like there's no signal. Initiating the landing sequence without clearance. Fingers crossed.
Landing your spacecraft would kick up clouds of dust that would take several minutes to settle down in the soupy atmosphere. As it clears, you'd look up into the sky, but you wouldn't find the familiar yellow circle of the sun. On Venus, it always looks like dawn, no matter what time of day it is. That's because the Venusian atmosphere only lets about 10% of the sunlight that hits it reach the surface. But wait, what were we saying earlier about the space probe that landed on Venus? Oh yeah, Venera 13. This Soviet probe made its fatal landing back in 1981. It survived the descent and lasted for a whopping 127 minutes. That's longer than any other spacecraft that had made it to the surface. But then, Venera 13 gave way to the violent, uninviting environment of this hell. It was likely crushed under extreme pressure. Or it melted. But it's too late to turn around now. You've lived through the 1 hour long landing and you're so close. All you need to do to complete your mission is to spend 5 seconds out there. Yeah, out there. In the most extreme environment you've ever been to. You made it! Whoa, the atmosphere is so strange. You can hardly lift your arms. Even though Venus has about the same gravity as Earth, you'd be feeling the sheer weight of its immensely dense air. It would feel like you were walking through water. Very hot water. And you'd be glad you were wearing so much protective gear. A quick look at your thermometer would tell you that it's a sweltering 475 degrees Celsius out here. That's hot enough to melt lead. Your pressurized suit would be working hard to keep you safe. Without it, you'd be crushed under all that pressure before you could even complete your mission. This isn't so bad after all. Hey, if a spacecraft could last over 2 hours some 40 years ago, well, you and your shiny new gear can survive longer, right? Venus is right here for you to discover. Just take a few more steps. Suddenly, something distracts you from the first ever first-hand human analysis of Venus's surface conditions. Your protective suit breaks. The drastic pressure shift would immediately make you feel like you were deep underwater. With an atmospheric pressure 90 times that of Earth, Venus would be crushing you from all directions. At the same time, you'd be struggling to breathe in an atmosphere without any oxygen. Any atmosphere you did manage to inhale would scald the inside of your mouth and the top of your throat. Unless you could scramble very quickly back to the safety of your spacecraft, you'd be dead within seconds. Hey, it could be worse. High above you, sulfuric acid clouds would be raining acid. But in this unbearably hot environment, the toxic rain wouldn't reach the surface. It would evaporate long before that. So at least you wouldn't have to worry about acid dissolving your skin and bones. That would be kind of gruesome. You know, in hindsight, maybe we shouldn't have sent you down to explore this hellish surface. We probably should have terraformed Venus into a more hospitable planet first. 635 light years away from Earth, there's a world covered in liquid ocean. A world where you wouldn't die a horrible death.
Probably. Welcome to Kepler 22b.
Hey y'all, I've got an exciting mission to land on and explore a planet that could be Earth 2.0. What if guy got tired of sending me to die in the solar system, so this time I'm traveling to an exoplanet where I might actually have a chance to survive. Exoplanets are like planets in our solar system, except they orbit different stars. They're cool, but there's just one problem. Exoplanets are really far away. So your solar system is this tiny little neighborhood with planets and moons orbiting around a sun in its center. And potentially, light years away, there are billions of other tiny little neighborhoods left to be explored. And you might have heard of the exoplanet that I'm going to. It's called Kepler 22b. It's not that far. Okay, only 635 light years. I'll be there in no time.
Even with advanced propulsion technology, a spacecraft traveling at 20% of the speed of light would require 3,175 Earth years to reach Kepler 22b.
Buzzkill. Well, luckily, I'm at a spaceport, and they have this, warp drive technology. So I'll be there in a jiff.
The warp drive technology allows a spaceship to travel faster than light by bending space-time. The warp drive creates a bubble around the ship, moving it through space safely 99.7% of the time.
Yeah, Rico, technobabble, blah, blah, blah. Never tell me the odds, kid. Let's do this. Well, hello, Kepler.
The Kepler 22 star system is a lot simpler than our solar system. It's only got one exoplanet in it. But this exoplanet, named Kepler 22b, is intriguing. It orbits within the star's habitable zone. And that means one important thing.
Alien civilization.
Water. It means water.
Oh.
Whenever a planet is in the habitable zone of its star, it means that the temperature is warm enough for water to remain in a liquid state, instead of evaporating, like it would, say, on Venus, or freezing like it would on Mars. And the Kepler 22 star is almost exactly like our Sun. It's a slightly smaller G-type star, which means it has a surface temperature of around 5,500 Kelvin. That's 5,200 degrees Celsius. Not too bad for a distant star system, except one thing. This exoplanet, Kepler 22b, is a lot bigger than Earth.
I don't see how that's a problem. It's just more surface to love. I mean, sure, it might have stronger gravity or, like, earthquakes. Kepler quakes? But, like, Earth has earthquakes too, and it's doing just fine.
The larger size of the exoplanet might indicate the presence of a thick atmosphere, leading to high surface pressure. This could result in water existing in a supercritical state, neither a true liquid nor gas, making it less suitable for life as we know it.
It's true, scientists think Kepler 22b might be covered with a liquid ocean, but they can't be sure what that ocean is like. Your mission is to land down there and test the water and the atmosphere.
Yeah, I was just gonna, land. So, here goes the landing sequence. Whew. It's been almost an hour, and all I see is water. Water! Everywhere water! I think I can land here. Seriously, Kepler, you are one disappointing exoplanet. Rico. Wake me up if you see any land.
My sensors read land right below us. You are cleared for landing.
Seriously? I can't even take a nap. Ugh. Okay, let's land. Whoa, this atmosphere is thick. Rico, give me some stats on this planet.
Kepler 22b is a super-Earth, 2.1 times larger and 9.1 times more massive than Earth. It has an orbital period of 289.9 Earth days. It also has water.
Oh, does it? Does it have water? Oh God, thank you so much, Rico. You know, the atmosphere actually kind of looks breathable too. You know, this started out super annoying, but this is actually kind of cool.
Analyzing Kepler 22b atmosphere.
You do that. I'm gonna go see what's out there. Interesting. Oh. That feels nice. I can go skinny dipping in here.
That would violate YouTube's terms of service.
Not if it's a music video, technically. Ooh, Rico, what's the temperature out here? I'm starting to feel like some warm bread in a toaster. Toasty.
The equilibrium temperature on Kepler 22b is estimated to be 22 degrees Celsius. However, my sensors pick up a much higher surface temperature.
If Kepler 22b has a thick atmosphere, it would cover the planet like a blanket, heating it up and turning it into an exoplanetary Venus. If the temperature becomes too high, all the water will turn into vapor and Kepler 22b will stop being a habitable world. On the other hand, if Kepler has no atmosphere, well, it might become a frozen world. It would be incredibly cold at night because with no atmosphere, there would be nothing to retain the heat from the day.
That sounds just like Mercury. Not my favorite planet. My favorite planet is Uranus. Kepler 22b, it seems okay. It's a little tough to walk here.
The surface gravity on Kepler 22b is approximately 2.07 times the gravity of Earth.
Yeah, thanks. I noticed that one, Rico. Hey, have you analyzed the atmosphere yet?
Analysis in process.
Oh, so the answer was no. You're still okay.
The thick atmosphere of Kepler 22b likely contains high levels of hydrogen and helium. Those are two gases that are common on larger planets. But if there isn't any oxygen in the atmosphere, you wouldn't be able to breathe. What you should also worry about is the water. It could be acidic or contaminated with toxic elements like heavy metals. Exposure to the body could prove fatal.
Great. So, there's water on Kepler 22b, not that I can drink it, and the atmosphere's in place, and the temperature's all right. What am I missing? Where's all the life?
If life exists on Kepler, it might be microbial. You wouldn't be able to see it without special equipment.
Did you hear that?
My scans are not picking up any life forms.
I gotta check this out. I just need a break first. All this walking around makes me sore. I gotta sit down for a second. I just need to catch my breath.
The atmosphere analysis is not complete.
It's okay. 1 second's not gonna kill me.
Analysis complete.
Something's wrong.
The atmosphere caused your lungs to collapse as a result of barotrauma.
Okay. Thank you.
It looks like the sudden increase in pressure forced the air in Chase's lungs to compress and rupture. One internal organ failure after another, and just like that, he's gone. But don't worry, he'll show up for his next adventure.
So that's the current version of Chase. We've done a lot around here to make that show happen. We've added more to our VFX team, we're doing motion capture, and we're creating whole worlds in Unreal Engine. That's the same tool used to make video games like Fortnite, Rocket League, and Gears of War. So congratulations to the whole video team for making that show look fantastic. You can find a lot of Chase's adventures here on the What If channel, but for even more Chase Dies in Space, well, he's now got his own YouTube channel. Okay, now for our most watched video ever. 25.5 million views. I've mentioned the pandemic a couple times during this show. I know nobody wants to think about it anymore, me either. But What If did a lot of hard work during the pandemic. Aside from learning how to collaborate on and produce videos while navigating work from home for the first time, we took care of people. We held a telethon on YouTube raising money for Doctors Without Borders as the healthcare providers of the world struggled to keep up with the disease. We produced a lot of informational videos on what the virus was, how it acted, and how it mutates, trying to cut through the misinformation. But no video was more popular than the one we released just days into the COVID lockdown, well before a vaccine, explaining to people everything we could about the virus that was terrifying the world.
This is SARS-CoV-2. It belongs to the family of coronaviruses named for the crown-like spikes on their surfaces. SARS-CoV-2 can cause COVID-19, a contagious viral infection that attacks primarily your throat and lungs. What actually happens in your body when you contract the coronavirus? What exactly causes your body to develop pneumonia? And how would a vaccine work? The coronavirus must infect living cells in order to reproduce. Let's have a closer look. Inside the virus, genetic material contains the information to make more copies of itself. A protein shell provides a hard protective enclosure for the genetic material as the virus travels between the people it infects. An outer envelope allows the virus to infect cells by merging with the cell's outer membrane. Projecting from the envelope are spikes of protein molecules. Both a typical influenza virus and the new coronavirus use their spikes like a key to get inside a cell in your body, where it takes over the cell's internal machinery, repurposing it to build the components of new viruses. When an infected person talks, coughs, or sneezes, droplets carrying the virus may land in your mouth or nose and then move into your lungs. Once inside your body, the virus comes in contact with cells in your throat, nose, or lungs. One spike on the virus inserts into a receptor molecule on your healthy cell membrane like a key in a lock. This action allows the virus to get inside your cell. A typical flu virus would travel inside a sac made from your cell membrane to your cell's nucleus that houses all its genetic material. The coronavirus, on the other hand, doesn't need to enter the host cell nucleus. It can directly access parts of the host cell called ribosomes. Ribosomes use genetic information from the virus to make viral proteins, such as the spikes on the virus's surface. A packaging structure in your cell then carries the spikes in vesicles which merge with your cell's outer layer, the cell membrane. All the parts needed to create a new virus gather just beneath your cell's membrane. Then, a new virus begins to bud off from the cell's membrane. Now, with the virus spreading in your body, how can you develop pneumonia symptoms? For this, we'll have to look into your lungs. Each lung has separate sections called lobes. Normally, as you breathe, air moves freely through your trachea or windpipe, then through large tubes called bronchi, through smaller tubes called bronchioles, and finally into tiny sacs called alveoli. Your airways and alveoli are flexible and springy. When you breathe in, each air sac inflates like a small balloon. And when you exhale, the sacs deflate. Small blood vessels called capillaries surround your alveoli. Oxygen from the air you breathe passes into your capillaries, and then carbon dioxide from your body passes out of your capillaries into your alveoli so that your lungs can get rid of it when you exhale. Your airways catch most germs in the mucus that lines your trachea, bronchi, and bronchioles. In a healthy body, hair-like cilia lining the tubes constantly push the mucus and germs out of your airways, where you might expel them by coughing. Normally, cells of your immune system attack viruses and germs that make it past your mucus and cilia and enter your alveoli. However, if your immune system is weakened, like in the case of a coronavirus infection, the virus can overwhelm your immune cells, and your bronchioles and alveoli become inflamed as your immune system attacks the multiplying viruses. The inflammation can cause your alveoli to fill with fluid, making it difficult for your body to get the oxygen it needs. You could develop lobar pneumonia, where one lobe of your lungs is affected, or you could have bronchopneumonia that affects many areas of both lungs. Pneumonia may cause difficulty breathing, chest pain, coughing, fever and chills, confusion, headache, muscle pain, and fatigue. It can also lead to more serious complications. Respiratory failure occurs when your breathing becomes so difficult that you need a machine called a ventilator to help you breathe. These are the machines that save lives and that medical device companies currently ramp up production for. Whether you would develop these symptoms depends on a lot of factors, such as your age and whether you already have an existing condition. While this all sounds scary, the push to develop a coronavirus vaccine is moving at high speed. Studies of other coronaviruses led most researchers to assume that people who have recovered from a SARS-CoV-2 infection could be protected from reinfection for a period of time. But that assumption needs to be backed by empirical evidence, and some studies suggest otherwise. There are several different approaches for a potential vaccine against the coronavirus. The basic idea is that you would get a shot that contains faint versions of the virus. The vaccine would expose your body to a version of the virus that is too weak to cause infection, but just strong enough to stimulate an immune response. Within a few weeks, cells in your immune system would make markers called antibodies, which would be specific for only the coronavirus, or specifically its spike protein. Antibodies then attach to the virus and prevent it from attaching to your cells. Your immune system then responds to signals from the antibodies by consuming and destroying the clumps of viruses. If you then catch the real virus at a later stage, your body would recognize it and destroy it. In other words, your immune system is now primed. Collecting evidence on whether this will be possible, safe, and effective is part of what's taking researchers so long to develop a vaccine. It's a race against time to develop a vaccine amid a pandemic. Each step in vaccine development usually takes months, if not years. An Ebola vaccine broke records by being ready in 5 years. The hope here is to develop one for the new coronavirus in a record-breaking 12 to 18 months. While all this will take time, stay home if you can, to protect the most vulnerable. And don't forget to wash your hands for at least 20 seconds and as often as possible.
Safe to say, everyone's glad that those days are behind us now. But the disease isn't gone. It's still a good idea to play it safe. I get vaccinated every year. Now, you do you, but just be aware it's still out there. Okay, as we wrap it up, I think that was a nice little walk down memory lane for me. Hopefully, if you've been a longtime fan, it was fun for you too. It was a bit cringy at times to listen to my voice in those early days, just as I'm sure it'll be cringy 10 years from now when I look back on the play-by-play of this past portrayal of produced parables and potboilers. It's the alliteration that's going to be really embarrassing for me. I know. But that's a story for another What If. Hey, What If fans! What a great day it is. Welcome to the program. I'm your host, Peter, and today we've got a jam-packed show for you. As per usual, we'll be doing a lot of crazy what-if scenarios, hypotheticals that'll thrill you, chill you, fill you, and ultimately kill you, but this show is special. It's the most popular what-if scenarios ever. That's right, the most popular videos that have ever graced the channel. We will be taking you through such diverse elements as dying on every planet in our solar system. We'll meet a time traveler, fall into a pool of piranhas, get swallowed by a whale, swallowed by piranhas, swallowed by a black hole, swallowed by Jupiter, and by a bit of quicksand. And I've got a fun little treat for you. But first, let's kick the bucket on every planet in our solar system. Well, not me. I'll let my astro-hopping assistant, Chase, handle that. If you landed on Venus, this hot planet would crush you like a plastic bottle. It would be painful, but don't worry, it would only last 5 seconds. The longest 5 seconds of your life. And just wait till you see what happens on Mars. It's unsettling. Venus has an extremely dense atmosphere, and with that dense atmosphere comes crushing pressure. Literally, it would crush you. The Venusian atmospheric pressure is 92 times higher than the pressure you experience on Earth. It would only take a millisecond before it started crumpling your spacesuit. After 1 second, your suit's integrity would be compromised. You'd be trapped in the imploding spacesuit with no way out. And that's when your body would begin to collapse. In the next 2 seconds, your skin and muscles would compress, your blood vessels would pop, your organs would fail. Finally, you'd lose consciousness, and just like that, you'd be gone. Venus looks like a beautiful place, but it's deadly. And being crushed by extreme pressure is just one of the many ways you'd die here. Remember the dense Venusian atmosphere? Well, not only does it create crushing pressure, but it also generates the greenhouse effect. Yeah, Venus is hot, instantly boiling your insides kind of hot. Even if you could somehow withstand all that bone-crushing pressure, the heat would get you.
Oh yeah, this feels hot, like being toasted. Like bread being toasted. You guys know what toast is.
Warning. Internal temperature rising.
The surface temperature on Venus reaches 465 degrees Celsius. That's almost as hot as the lava coming out of Earth's volcanoes. You'd be feeling the effect of this intense heat within seconds. After 1 minute, your internal temperature would start rising. Cue heat exhaustion.
What if, guy, I don't feel so good.
Body temperature. 40 degrees Celsius and rising.
At this point, you'd experience nausea, fatigue, and extreme sweating. Your internal organs would start to overheat.
It's getting dark. It's getting dark.
After 10 minutes, you'd lose consciousness. Now, you'd just have minutes left before suffering brain damage and complete cardiac arrest. Okay, quick brain fact. Did you know that curiosity is one of the only emotions that actually rewires your brain in real time? The moment you lean in to understand something, like you are right now, your neurons start building new pathways. When you watch curiosity-fueled content like this, your brain treats it like active learning, decoding and making sense of new ideas just like it does when you solve a puzzle. So, watching our shows is literally good for your brain. Well, that's why we launched the Popular Science Fast channel, where you can stream all our shows 24/7. Tune in any time of day and you'll find mind-bending science from us and from some of the world's leading creators, including NASA's spaceflight, Hacksmith, and Complexly. Plus, live rocket launches, documentaries, and deep dive specials. It's basically a non-stop feed of curiosity, always on, always learning. We're currently available on 10 different platforms, including Vizio, Roku, and Plex, but we're just getting started. We're reaching tens of millions of homes and streaming devices all over the globe, and that audience keeps growing every month. And the channel just keeps evolving. We're adding brand new series and specials monthly, from breakthroughs in tech to space exploration coverage you can watch live. It's a front row seat to the new space race, alongside a 150-year-old legacy of science storytelling now